From Mercury's sun-scorched ridges to Neptune's icy blue rings, the solar system has never looked more alive. Thanks to the sharp eyes of spacecraft like Cassini, Juno, Voyager and New Horizons, and telescopes like Hubble and James Webb, we're seeing our neighboring worlds in a new light. Each image captured isn't just a snapshot, it's a revelation. Moons we once dismissed as frozen rocks are erupting with geysers. Dwarf planets spin with impossible speed, and planets we thought we knew are cloaked in mystery. Join us as we take a look at the latest and most breathtaking images of our solar system's planets, moons, and forgotten wanderers. Mercury's new face revealed. For many years we forgot about Mercury. Mercury was long thought to be a dead rock because it was so close to the Sun and was in such intense heat and light. It was grey, burned and quiet. We mostly knew what we knew from a few flybys and fuzzy grayscale photos, like an unfinished drawing of a planet that no one wanted to finish. But now, we're finally seeing Mercury, really seeing it, in colour, in depth and in motion. It started with NASA's Messenger mission, launched in 2004 and orbiting Mercury from 2011 to 2015, Messenger changed everything. Using a suite of advanced cameras, it pieced together an incredible high-resolution mosaic of the planet's surface. The result was something no one expected. What looked like a dull grey rock suddenly came to life with burnt oranges, deep browns and soft blues. These are colours that can't be seen with the human eye, but were picked out by Messenger's multispectral images. It wasn't only science, it was a picture. Mercury had a paint set. It had a past. It hurt. The Caloris basin stood out like a scar on its skin as one of those cuts. Captured in stunning detail, the oblique view of Caloris basin taken by Messenger doesn't just show a crater. It shows the aftermath of cataclysm. Roughly 1,500 kilometers wide, almost the size of Western Europe, Caloris is one of the largest impact basins in the solar system. It was carved into Mercury's crust by an object that likely slammed into the planet at 20 kilometers per second. The result? A ripple of molten rock, frozen in time, mountains at its edges, fractures stretching for hundreds of kilometers. A circular wound so massive, it reshaped the entire hemisphere. The oblique angle reveals the depth, the curvature, the stark contrast between jagged highlands and smoother plains. You're not just looking at a crater, you're staring into planetary trauma. And just when we thought we'd seen all Mercury had to offer, Bepi Colombo arrived. Launched jointly by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, Bepi Colombo began its long, looping journey toward Mercury in 2018. It wasn't until September 2024, on its fourth flyby, that it finally came close enough to show us something new. And what it gave us was more than just photos. It gave us perspective. The now famous image wasn't a postcard, it was a love letter. In the frame, Mercury floats like a giant bruised pearl in the void. Its surface, a mosaic of ancient lava plains and impact scars, is bathed in sunlight. You can see the subtle glow of the thin exosphere, not quite an atmosphere, but not empty either. And around the edges, Bepi Colombo's instruments peek into frame. A reminder that this moment was stolen from deep space by a machine hundreds of millions of kilometers from home. The photo is annotated, sure, scientific, precise, but there's something deeply human about it. It's the way Mercury sits in the center, not as a mystery to be solved, but as an old friend finally letting us in. Bepi Colombo's images aren't just clearer, they're deeper. Scientists use them to study Mercury's crustal composition, analyzing subtle shifts in color and texture. New ridges, microcraters, and volcanic plains were mapped, features that didn't exist in our atlases just a year ago, and they're just getting started. Bepi Colombo is set to enter orbit in 2025, and when it does, it'll deploy 2 orbiters, one from ESA, one from JAXA, to scan the surface with lasers, magnetometers, and spectrometers. We'll know Mercury's gravity field, its magnetic heartbeat, even its core's secrets, from forgotten rock to front-page star. Mercury's reintroduction to the world is complete. The tiny world, the least looked into, the one that doesn't have any moons, rings, or atmosphere. We didn't like that one because it was too hot, too close, or too boring. Following its flybys, giving its holes names. Ashes from a volcano and impact glass were used to paint it, finding beauty where it wasn't thought to be there before. Venus, through the eyes of fire and cloud. Venus is not the same as Earth. It might be the same size, mass, and structure, but that doesn't make it a sister. Venus is a warning sign for the rest of the solar system. It is a world where heaven was lost and hell took its place. We quote, "We've finally seen what hell looks like thanks to a few probes and spaceships with hearts that can handle heat and radar eyes." Our first true look beneath Venus's eternal storm came from the Soviet Union. In 1982, Venera 13 did what no mission had ever done. It landed on Venus and survived long enough to send back color images before it was crushed and fried alive. The image it captured is eerie, beautiful, brutal. Dark, flat pieces of volcanic rock are spread out over the orange-colored ground. There is a faint yellow light in the sky. The only thing you can see is fog. You don't see the world. You can feel it. It's 92 times stronger there than on Earth, where the heat makes lead melt, where sulfuric acid rains down in a way that makes the air thicker than your worst fears. Despite that, the picture is still clear. Venus seemed to want us to see, one time only. No other surface photo of Venus has ever matched it, and honestly, nothing else likely will, not until someone tries to go back. But we don't need to touch down to know more. We learn to see through Venus. In the early 1990s, NASA's Magellan spacecraft orbited Venus and mapped nearly the entire planet using radar imaging. One image, a surreal 3D rendering from February 1996, shows us Gula Mons, a volcano that towers 3 kilometers above the Venusian plains. Venus has more volcanoes than any other planet, possibly tens of thousands of them, and some of them might still be active. The radar maps reveal lava flows, ridges, and domes that suggest not a dead world, but one that might be quietly boiling beneath. In the Magellan view, Gula Mons rises like a beast, its slopes streaked with hardened flows. It doesn't erupt violently. It oozes, slowly, endlessly. This image is sculptural, like a ghost frozen mid-scream. But what you see is only half the story. You have to look up to really know Venus. The Hubble Space Telescope caught a very interesting picture on January 24, 1995. Hubble used ultraviolet images to look through the planet's thick clouds and see parts of the atmosphere that humans can't see. In the photograph, Venus becomes a swirling orb of purples and pale blues. But most striking of all is a giant Y-shaped pattern near the equator, a signature that had been seen before by Mariner 10 and Galileo, but never this clearly. This Y isn't just a coincidence. It's an atmospheric wave, hundreds of kilometers long, spiraling through Venus's upper atmosphere like a jet stream from another dimension. It's caused by high-speed winds shearing and folding clouds of sulfuric acid. These clouds, the darker patches in the image, show concentrations of the acid floating high above the surface. And just like Earth, Venus has jet streams and weather patterns. But unlike Earth, Venus's atmosphere rotates 60 times faster than the planet itself. One full spin of Venus takes 243 Earth days, but its clouds whip around in just 4. The planet's upper air is faster than its land. Its skies race ahead of its time. Why does this matter? In spite of its chaos, Venus may have once been a good place to live. Scientists think that Venus had oceans, rain, and maybe even conditions like Earth for billions of years before the greenhouse effect got out of hand and turned it into a furnace. The thick clouds that are covering the sky right now could be the last signs of a broken climate system. And the ultraviolet images from Hubble might contain secrets about how climate dies. They show us where the heat is trapped, where the chemistry changed, and where the balance tipped from atmosphere to apocalypse. Looking at those images, we're not just learning about Venus, we're learning about Earth's possible future. So what do we have now? One ghostly photo from the surface, where a probe gasped in its final seconds. One radar-scanned volcano rising above a sea of lava plains. One ultraviolet swirl of clouds and acid, hiding a story older than Earth itself. Earth in motion and in memory. Every day we see Earth, in person, shown in photos, in windows and weather tools. It's not the same thing to look at Earth and really see it as if it were the first time. When you look at Earth from space, it looks like something else, not at home, not background, but a miracle that is alive, spinning, breathing. And thanks to the latest images from orbiting satellites and passing astronauts, we're seeing our planet as we've never seen it before. Radiant, vulnerable, and caught in motion. A full-disk, true-color image of Earth, captured by Himawari 8, a Japanese weather satellite launched in October 2014, but still producing some of the most stunning high-definition images of Earth to date. There are no edges around the picture, no names. Do not talk about politics. Earth just the way it is, blue, white, and living. You can see the deep blue of the Pacific Ocean, which is covered in swirling thick clouds. Australia is like a gem that has been baked in the sun. That thin ring of life, the atmosphere shines with light in its curve. And this isn't a one-time capture. Himawari 8 takes images every 10 minutes, giving us a nearly real-time portrait of our planet. It's not just data for meteorologists. It's a heartbeat monitor for the Earth itself. From hurricanes forming off coastlines to dust storms sweeping across deserts, these images show a planet in constant conversation with itself. But then comes the view that takes your breath away. A star trail image taken from the International Space Station, orbiting 400 kilometers above the surface. At first glance, it looks like art, an abstract blur of streaks and sparks. But look closer. You'll see Earth's cities blazing like veins of fire stretching across continents. The long exposure captures what the naked eye can't, such as the spin of the Earth below, the arcs of stars in motion above, and even the aurora, rippling in shades of green, red, and violet near the edge of sunrise. With the first light of dawn, a solar screen comes into view. Earth, the stars, its satellites, and its atmosphere were all caught in a single 30-minute hug. It's not just a picture, a time-lapse of daily life in space, a warning that the Earth moves while we sleep. The stars move, the sun comes back. But Earth isn't always peaceful in these images. Sometimes the beauty is terrifying. On October 6, 2024, the GOES satellite captured a monstrous spiral churning through the Atlantic. Hurricane Milton bearing down on Florida. The image is stunning and ominous. A beautiful cluster of clouds that is hundreds of miles across. A dark pupil-like eye staring straight at the coast. Storm bands that reach out across the seas and the sky. But what really matters is what's inside the picture. The power, the heat, the chaos. Hurricanes like Milton form from warm ocean waters. The GOES satellite uses infrared sensors and lightning mappers to track them in real time, saving thousands of lives with every early warning. But the beauty of the satellite image can make you forget. This is destruction on a planetary scale. Winds topping 200 kilometers per h. Torrential floods. Shattered homes. From space, it's mesmerizing. On the ground, it's devastating. It's this contradiction that defines Earth photography from orbit, a planet of peace and violence, light and shadow, wonder and warning. These aren't just images, they're reminders of perspective. From a camera hundreds of miles up, you see Earth differently. You see its thinness, the fragile bubble that shields all life. You see its glow, not just of lights and cities, but of motion, weather, and energy. And you see yourself, not directly, but in reflection. Mars in layers of dust and time. Mars used to be just a little red dot in the sky at night. We now know the name of this area. Its fields have been driven across, climbed its hills. I saw its rains get worse and calm down. Every picture we see is more than just a picture of another world. It's a look into our possible future, a reminder of Earth's long history, and a promise of where we might be one day. One of the most breathtaking views came from Perseverance, NASA's most advanced rover, which landed in Jezero crater in 2021. On September 27, 2024, while climbing the crater's western wall, Perseverance captured an enhanced color mosaic that stunned even veteran scientists. The image revealed layered sediment, streaks of oxidized minerals, and ridgelines shaped by what was once, long ago, flowing water. The colors were false in a technical sense, used to highlight different materials, but they brought the scene to life. Pinks, rust reds, pale grays, like a desert painting unraveling beneath an alien sky. And then, in the distance, the faint outline of a crater rim where Perseverance had started its journey years earlier. Jezero crater was chosen because it was once a lake. Billions of years ago, water carved river channels into the crater and deposited clay-rich sediments, creating a perfect site to look for signs of ancient microbial life. This photo wasn't just a snapshot, it was a bookmark in the search for biology beyond Earth. But Mars doesn't always sit still for the camera. In 2021, between June 26th and September 4th, the Hubble Space Telescope watched from Earth's orbit as a planet-wide dust storm began to swirl across Mars. One of the images from this event, captured during the height of the storm, shows Mars almost completely obscured. A ghost planet, wrapped in ochre haze. These storms are different from anything we see or experience on Earth. With speeds of up to 100 kilometers per hour, dust storms on Mars can cover the whole world. They may last for weeks or even months after they start. The atmosphere is only 1% as thick as Earth's, so there isn't any rain to keep the dust down. Only time will do that. Hubble's view of the Martian storm is both haunting and humbling. You can barely see surface features. The familiar red tones are dulled, hidden beneath a choking cloud of fine particles. For rovers on the ground, these storms can be dangerous, blocking solar panels, obscuring cameras, and sometimes ending missions early. But from space, they're majestic in scale, entire continents swallowed by wind. The Curiosity rover, which landed in 2012, has spent over a decade climbing Mount Sharp, a massive layered mountain rising from the center of Gale Crater. One particular close-up from August 23, 2012, captured with Curiosity's 100mm mast camera, shows the mountain's sedimentary layers in astonishing detail. The bands are easy to count. Some are as thin as paper, and some are as thick as rocks. Each one marks a different time in the past of Mars's temperature. The base layers most likely formed in a lake a long time ago. The top layers, which are dusty, dry, and worn away by wind, show that the planet changed, dried out, and became hard. Dust that is high in iron and chemical weathering have made the colors change from yellow beige to deep rust. Even the shadows look old. It's like seeing the remains of a world that never built towns, but still has the signs of time on it. And in the foreground of the photo, Mars itself, sharp stones, dusty ridges, a barren road where no tire but a robot's has ever rolled. These aren't just pictures of nature, they're tales. There is stress in every picture of Mars because of what it is and what it was, among the dust and the data, between death and the very small chance of living. They look at more than just rocks. They see rivers from the past, temperatures from long ago, and maybe, just maybe, fossilized proof that we're not alone in the universe. Jupiter in light beyond the eye. It's hard to tell what planet is which because Jupiter is so chaotic. A huge, spinning mass of gas, weather, and gravity that is so strong it could swallow every other planet and still have room for more. And yet, for centuries, all we had of Jupiter were dots and stripes, blurred glimpses through telescopes, interrupted by Earth's atmosphere and our limited reach. Today, Jupiter has finally stepped into clarity, not through just one camera, but through a symphony of eyes, orbiters, infrared telescopes, and citizen scientists. Start with the most recent jewel, the infrared image of Jupiter taken by the James Webb Space Telescope in 2022 and refined through 2024. This wasn't just another snapshot, this was Jupiter seen in a different kind of light, invisible to human eyes, but translated into glowing color by Webb's Makem and NeoSpec instruments. Jupiter's Great Red Spot, the solar system's most iconic storm, glowed in stark relief. Not red this time, but luminous white and electric blue, like a cosmic eye staring back at us through veils of heat. The spot stretches wider than Earth itself, and in infrared, its towering clouds shine like phosphorescent waves in a black sea. Around it, Jupiter's bands of gas, its belts and zones, ripple like molten ribbons. The polar regions reveal auroras, great arcs of charged particles crashing into magnetic fields. And for the first time, we could see the planet's heat signatures dancing in real time, as if Jupiter itself were breathing light. This picture wasn't art, it was science made clear. Juno, on the other hand, is for motion, drama, and the whole solar show. During its 65th close pass of Jupiter on September 20th, 2024, NASA's Juno probe did a dizzying dive over the gas giant's north polar region. It took a series of pictures that make you feel like you're watching Jupiter breathe out. In one of the photos, you can see it. Not just the top of the planet, but the depth. Vortexes the size of continents spiral across the poles, each spinning storm surrounded by smaller eddies, like the eye of a hurricane flanked by a dozen siblings. Juno flies in an elliptical orbit, taking it as close as 4,200 kilometers from Jupiter's cloud tops. From this range, its camera, JunoCam, doesn't just take pictures. It captures texture, depth, motion. The north pole of Jupiter looks nothing like the equator. Instead of neat horizontal bands, it's chaos. Cyclones arranged in polygonal patterns, some stable for years, others shifting over days. These aren't ordinary storms. They're structures held together by the planet's rotation, magnetism, and sheer size. One of the most iconic images, created by citizen scientists Gerald Eichstadt and Sean Doran using raw data from JunoCam, shows Jupiter's cloud belts in enhanced color. It makes you feel hypnotic. Rusts deeply, whites that are creamy, bright teals. The picture isn't a fantasy. It's an improvement meant to bring out the small changes in temperature, altitude, and makeup that make up each stripe of Jupiter's body. It looks like a rock made of smoke and lightning. The gas giant turned into a Renaissance picture. It has a personality, even though it's just clouds of hydrogen, helium, and ammonia moving around. A beat, a memory from long ago, because these clouds are old. Some of them have lasted centuries, like the Great Red Spot. Others rise and fade in weeks, depending on the sun, the heat below, and internal dynamics we're still only beginning to understand. Jupiter is more than a planet. It's a weather machine, a failed star, a magnetic titan whose presence shapes the orbits of comets and shields the inner solar system from cosmic debris. Now that we have these new pictures, from JWST's sharp infrared view to Juno's dive into the middle of its storms, we can start to map what we thought was impossible to map. Now we're not telling stories about a king of the gods, but about a world that is always changing. Saturn, the ghost in the rings. Saturn has always been a place where people dream, the one with rings that look too beautiful to be real, rings that sparkle and don't make sense. When seen from Earth, Saturn looks like a round disk with a ring around it. From space, though, that image falls apart into something weirder. Saturn isn't just beautiful, it's haunted by motion, light, shadow, storms that don't spin but fold into hexagons, rings that breathe and flicker, and the deeper we look, the more surreal it becomes. One of the most poetic images ever taken of Saturn came from NASA's Cassini spacecraft on February 3, 2017, an image of Saturn's own shadow stretching across its rings. In the photo, Saturn isn't front and center. Its presence is implied. You see the rings, thin, icy, fragile, and then you see them darken, as if someone turned off the lights halfway through. That's Saturn's shadow, projected onto the rings like a celestial sundial. The angle makes it feel alive, as if the planet is watching from just off frame, leaving only its silhouette behind. This isn't just art. It's geometry on a cosmic scale. The shadow reveals how the planet tilts, how the rings extend, how sunlight arcs through the system at just the right angle to paint with darkness. Cassini orbited Saturn for 13 years, and in that time, it turned the gas giant from a distant wonder into a layered, breathing world, a place with weather, magnetism, and mysteries that still refuse to sit still. One of the most well-known? The polar hexagon in the north. The 2013 picture of the hexagon, taken in full color by Cassini's wide-angle camera, is not a visual illusion. The jet stream has 6 sides and is about 30,000 kilometers wide, which is longer than 2 Earths put side by side. That thing is spinning. The enhanced color image shows it well. A massive yellow polygon sitting squarely on Saturn's north pole, framing a deep hurricane-like eye in the center. Red, green, and blue filters blended together give the globe a holiday ornament look. But don't be fooled. That ornament is moving at speeds of over 300 kilometers per h, with winds circling the pole in a path that defies easy explanation. Why is it a hexagon? Scientists think it's a natural result of fluid dynamics, or the way that fluids that are spinning organize themselves in certain situations. But why is Saturn the only place it could be? That's still a puzzle. And deep in Saturn's atmosphere, there are some secrets that would rather stay that way. But even Saturn's rings, which are its most famous feature, won't be quiet. In late 2024, the Hubble Space Telescope spotted something strange: the return of the spokes. In an image taken ahead of Saturn's autumnal equinox on May 6, 2025, you can see them. Faint, radial shadows streaking across the rings like bruises on a record. Some are straight, others warped. Some appear light, others are dark. They shimmer, they vanish, then they come back. What are they? The main idea is that these spokes are made up of very small charged particles that are lifted above the rings by Saturn's magnetic field. When the sun hits just right, like around the equinoxes, the balance of light, solar wind, and magnets is thrown off for a short time. Dust goes up. There is static. The rings also show us their secret heart. But it's still a theory. The truth is, no one has yet confirmed exactly how or why they form. They aren't constant. They don't follow a pattern. And sometimes they look more like shadows cast by ghosts than any known object. Its rings, once thought ancient and eternal, might be shockingly young, possibly no more than 100 million years old. Its storms, some of which span thousands of kilometers, erupt with lightning bursts 10,000 times stronger than Earth's. Its magnetic field tilts, its poles shift, and the entire planet pulses with a rhythm only a few missions have even begun to decode. Uranus, the planet that spins on its side. Uranus was an accident in the universe for hundreds of years. It was just a pale blue dot tucked between Saturn's rings and Neptune's winds. The color didn't flash, storms didn't hit it hard, it just rolled, in peace, sideways. Thanks to the James Webb Space Telescope, Hubble, and groundbreaking radio observations, we've begun to peel back the bland exterior and see Uranus for what it really is. A tilted giant with an icy heart, glowing rings, eerie moons, and storms that bloom in the dark. Start with the picture of Webb. This near-infrared picture, taken by Makem on JWST, is not only clear, it's beautiful. In space, Uranus looks like a bright blue ball with a halo that is almost too thin to touch. While you look more closely, things start to look odd. There will be a bright white polar cap over the northern hemisphere, which is a yearly event that scientists are still trying to figure out. Uranus's poles aren't set in place like Earth's are. The world tilts 98 degrees to its side, so each pole faces the sun for a different amount of time. This image reveals that the North Pole is basking in light, which may explain the polar brightening. What we're seeing isn't just illumination, it's seasonal transformation. On Uranus, each season lasts 21 Earth years, and as one hemisphere plunges into darkness, the other flares to life. Yes, Uranus has rings, 13 of them in fact, and JWST captured them in haunting clarity. Both the dim inner rings and the thin outer ones shimmer in the image, more like spiderwebs than Saturn-style hoops. They're dark, narrow, and faintly reflective, made of icy debris and dust. And as if that weren't enough, the image also reveals 9 of Uranus's moons, like a clock face surrounding the planet: Juliet, Portia, Rosalind, Puck, Bianca, Desdemona, Cressida, Belinda, and Perdita. They are irregular, quiet, and in some cases chaotic, tumbling rather than spinning. But together they complete the portrait, a lopsided planet caught in a slow, graceful dance with its twisted children. From there, Hubble takes over. Its ultraviolet composite shows something even stranger: auroras glowing over Uranus's poles. These are planetary light shows, created when charged particles from the solar wind crash into the upper atmosphere. But Uranus doesn't have a standard magnetic field. Unlike Earth or Jupiter, its magnetic field is both tilted and offset, emerging not from the core, but from somewhere lopsided and off-center. The result? Auroras that don't form neat ovals like Earth's, but instead flare unpredictably across the surface. They flicker like broken neon signs, bending around the planet's curves. In Hubble's view, the auroras appear as bright glowing spots, bursts of ultraviolet light, sometimes matching solar activity, sometimes not. It's a reminder that even the most boring planets are still under siege from space. And then there's the most recent discovery. In a series of images collected using microwave wavelengths, NASA researchers spotted something never seen before: a polar cyclone on Uranus. In 3 filtered images, each tuned to a different frequency, you can see it. A faint, light-colored swirl just right of center, nestled near the planet's pole. A cyclone on Uranus. It's not as fierce as Jupiter's storms, but its mere existence challenges what we thought we knew. Uranus had been thought to be pretty quiet up until now. There is no big great red spot, there are no lightning strikes. But this storm, which is the first one ever seen on Earth, tells a different story. It means that heat is going inside, that the inside isn't as still as thought. Uranus has weather systems hidden beneath those calm blue clouds. These systems are controlled by the planet's own heat and the changing of the seasons. That brings us to the bigger picture. Uranus might be one of the solar system's least known planets, because it's not flashy, but because it's quiet. It's not easy for it to reveal its secrets. Its rings are not very bright. It doesn't have many storms. Its seasons last for many years. Its tilt doesn't make sense, and its moons aren't balanced. But now we're seeing the truth. Not a gas giant, but an ice giant, packed with water, methane, and ammonia deep below the cloud tops. Not a quiet world, but a mysterious one, bent, frozen, and slowly revealing its strange anatomy. Not just a blue dot, but a spinning monument to the weirdness of the solar system. Neptune, the wind-slashed giant of the outer dark. The planetary train track ends at Neptune, which is the farthest planet from the Sun. It orbits in a space so cold and far away that it takes sunlight 4 hours to reach Neptune. We had a rough idea of what Neptune looks like for a long time. Dots of blue light, smooth spheres with no edges or corners. It was simple to think that not much was going on outside. In late 2022 and into 2024, the James Webb Space Telescope delivered a jaw-dropping infrared portrait of Neptune, a world wrapped in subtle beauty and layered mystery. Gone is the cartoonish blue. Instead, Neptune appears as a silvery orb, glowing with bright, high-altitude methane clouds. Its thin rings, rarely visible even with powerful telescopes, encircle the planet like sharp etchings on glass. These rings had only ever been clearly seen once before, by Voyager 2 in 1989. Now, thanks to JWST's crisp resolution, they shimmer again, delicate and defined. But Webb's image reveals something else too: moons. 7 of them. There's Naiad, Thalassa, Despina, Galatea, Larissa, Proteus, and dominating the view like a misplaced star, Triton. Triton is Neptune's biggest moon, and it really stands out, clear and bright. Triton is much more reflective than Neptune itself. This is because Webb's mirror shape makes ripples in the light that hit it. That's because nitrogen frost covers its surface and bounces back most of the sunshine that hits it. But behind that, beauty is a terrible past. Triton and Neptune were not born together. The object was caught. It was probably a Kuiper belt object that got too close. Since then, its backwards orbit has been a slow-motion collision course toward Neptune, a dance that may eventually tear Triton apart. But even as we admire Webb's clarity, we owe our deepest insights to an older guest, Voyager 2. In 1989, the spacecraft flew past Neptune, giving us our first close-up look at the giant, and revealing a storm no one expected, the Great Dark Spot. This wasn't a copy of Jupiter's Great Red Spot. It was different. Darker, colder, transient. The image taken by Voyager's narrow-angle camera shows a vast oval spinning through Neptune's atmosphere, bordered by high white clouds whipping past at supersonic speeds. Wind speeds on Neptune can exceed 2,100 km per h, 1,300 miles per hour, the fastest in the solar system. And just like that, a cold, quiet planet became something else entirely, a howling hurricane of gas and ice. But Neptune's story didn't end with Voyager. Between 1994 and 2020, the Hubble Space Telescope observed Neptune's atmosphere in ultraviolet and visible light, producing a time-lapse of cloud activity spanning nearly 3 decades. What it showed was stunning. Storms formed and disappeared. Dark spots faded, migrated, and reformed. High clouds shifted latitude. Neptune wasn't static, it was evolving, dynamic, alive. We saw a dark storm in the northern hemisphere drift westward, then vanish before reaching the equator. An atmospheric behavior not yet fully understood. Some storms were accompanied by companion clouds, bright streaks at the edges of giant weather systems, possibly formed by shock waves or vortex boundaries. This long-term monitoring gave scientists a new understanding. Neptune's cloud activity might be tied to the solar cycle, even from nearly 4.5 billion kilometers away. Somehow, even at the edge of the Sun's influence, the planet listens to the beat of its star. What does Neptune really mean? It makes no sense. An ice giant, but the sky is rough. A world that is covered in methane and has white clouds flying through it. A place where the seasons last 40 years, but the weather changes every day. Its insides are still a secret. It may be an ocean of superionic water, where hydrogen and oxygen move around like a metallic soup. Its magnetic field isn't lined with the axis and tilts all over the place. Its rings are small and new, so they might not last forever. And then there's Triton, orbiting backward. A cold moon with geysers, an icy crust, and a past stolen from somewhere else. In the JWST image, Triton and Neptune almost seem to be in a standoff. One icy rebel, one howling king. Both are reminders that even in the coldest corners of space, the story never stops. Pluto, the dwarf planet with a beating heart. Pluto was a cosmic joke for most of the 20th century. It was the little guy, the ninth world, the cold outcast at the edge of the solar system. After that, it wasn't even a planet. But in 2015, something happened. NASA's New Horizons spacecraft flew past Pluto after a decade-long journey, and in an instant, everything changed. Pluto was no longer a mystery. It was alive. And the images it sent back are still rewriting what we know about worlds beyond Neptune. Start with the most well-known. Tombaugh Regio, Pluto's huge heart-shaped basin, can be seen on the left side of the small planet in a picture that has become famous. Sputnik Planitia is in the middle of it. It is a huge, flat plain of nitrogen ice that is smooth, has no craters, and is surprisingly young. This picture, taken on July 14, 2015, from only 48,000 miles away, showed geologic action, which experts had not expected. The plain is divided into polygonal segments separated by thin troughs, a sign that the surface is convecting, slowly rising and falling like a pot of boiling nitrogen slush. Think about that. A place with no sunlight, colder than 230 degrees Celsius, is still moving under its own internal heat. Zoom in, and you'll see mounds, pits, and clusters. Features that speak of sublimation, freezing, and even potential cryovolcanism. Above the plain rise ice mountains twice the height of the Rockies, possibly made of frozen water, as hard as rock in Pluto's extreme cold. Shortly after its closest approach, New Horizons turned its camera back and captured one of the most haunting space images ever taken. Pluto backlit by the sun, surrounded by a ghostly blue haze. This farewell photo shows a delicate ring-like halo, Pluto's atmosphere. Yes, Pluto has one. It's thin, fragile, and composed mainly of nitrogen, with traces of methane and carbon monoxide. In sunlight, it glows blue due to small haze particles scattering light, much like Earth's sky. But unlike Earth, Pluto's atmosphere rises over 100 miles above the surface before fading into the void. This haze isn't just pretty. It tells us that Pluto's surface and sky are in constant exchange. Ices evaporate, rise, freeze, fall again. It's an active weather cycle in a world once thought dead. Pluto isn't just one color, though. In a different stunning collage, scientists made a better color picture of the different types of surface ice on Pluto, showing how diverse the planet really is. There are pinks, oranges, and grays on the top. Some places have a lot of gas, and others have a lot of water ice. Still others have a golden glow that comes from tholins, which are complex organic molecules that are made by radiation. In one 75-mile wide section, the textured plains curve around isolated ice mountains, hinting at a crust that may be broken and reformed by ancient tectonic forces. We don't just see geology, we see chemistry in motion. It has 5 moons, and the largest, Charon, is half its size. So large, in fact, that the two worlds orbit a common center of gravity outside either body. It's a binary system, dancing through the Kuiper belt. When Pluto and Charon come together, their gravitational pull is stronger than anything else in our solar system. But what makes Pluto stand out is that it won't stay still. It plays dead at the edge of the map. It has ices that move, several layers of air. Cryovolcanoes might happen. It could even have a liquid ocean under its shell, with anti-freeze-like chemicals protecting it and a core that is still warm enough to make heat. Ceres, the bright-eyed world between Mars and Jupiter. It was before New Horizons and Voyager flew by Neptune and Pluto's center. That's why NASA sent a probe into the asteroid belt. Ceres floats there between Mars and Jupiter. It is the biggest object in the belt and the first dwarf planet that a spaceship has been to. In 2015, the Dawn spacecraft slipped into orbit around Ceres, becoming the first mission to orbit 2 separate extraterrestrial bodies. It had previously visited Vesta. What it found wasn't a dusty rock. It came to light. The world's attention was drawn to Dawn's picture of Okator crater, an impact area 92 kilometers wide with an eye in the middle. There were bright white spots that looked like nothing else seen in the solar system. They stood out against the grey background. The image, ISO 1609b, shows them clearly, vivid, chalky deposits that shine like mirrors under the distant sun. These weren't just reflections. These were salt flats, rich in sodium carbonate, formed by briny water seeping up from Ceres's interior, then freezing and evaporating on the surface. And these bright spots change. New spectrographic observations suggested they glow differently throughout the day, likely due to temperature-driven processes. That means they're not ancient remnants, they're active. Ceres is still breathing. But how? The surface temperature hovers around 100 degrees Celsius. The answer lies beneath. Scientists believe Ceres has a brine-rich subsurface layer, possibly even a slushy ocean locked below its icy crust. Okator crater may be a vent, an open wound where heat from the impact melted through the shell and allowed salt water to rise. In a topographic map from Dawn, we see a rugged, color-coded landscape, reds for highlands, blues for lowlands, giving shape to an ancient, complex terrain. Ceres has craters, ridges, even ice volcanoes like Ahuna Mons, a mountain thought to be the youngest on the planet. It rises 4 kilometers above the surface, likely formed by cryovolcanism, where cold liquids erupt instead of magma. This kind of activity was thought impossible on such a small body. But Ceres defies expectations at every turn. And then there's the global view, the full disk image of Ceres, showing a muted greyish sphere speckled with pockmarks. From afar it looks calm, dead, but zoom in and you see scars of ongoing internal evolution. Like Pluto, Ceres may contain a subsurface ocean, preserved by salts that prevent freezing. And while it doesn't have an atmosphere in the traditional sense, it has been found to exhale water vapor, especially when exposed to solar radiation. In 2014, the Herschel Space Observatory detected plumes of water vapor streaming from Ceres, an astonishing discovery for a dwarf planet inside the frost line. It was the first unambiguous detection of water vapor on a solar system body without a thick atmosphere. That revelation catapulted Ceres into the category of potential astrobiological interest. Could microbes exist in its briny underworld? Could life find a foothold here, in the dark, under pressure? We don't know, but we do know that Ceres is not inert. It's layered. It's restless. It changes. It might not have the drama of Saturn's rings or the grandeur of Jupiter's storms, but it has something rarer, subtlety. Ceres doesn't shout, it whispers, and it waits. Right now, no mission is actively headed back to Ceres, though future explorers, robotic or human, may well stop by. Its location makes it a prime candidate for refueling depots or asteroid mining, but its secrets demand more than exploitation. Haumea, the spinning shard of the Kuiper Belt. Haumea is one of the weirdest things in the solar system. It orbits far beyond Neptune, where the sun is just a cold glimmer. It's not clear what Haumea is at first glance. It's a small planet far away, one of many frozen bodies in the Kuiper Belt that circle in icy silence. However, as scientists looked more closely, the puzzle grew and then broke wide open. Most large bodies in space are rounded by gravity, spheres, oblate spheroids, at worst, lumpy potatoes. But Haumea is shaped more like a football, elongated, distorted, stretched along its axis. Why? Because Haumea spins fast, really fast. It completes a full rotation every 4 hours, one of the fastest spins of any known object its size. That incredible speed has stretched the dwarf planet into an ellipsoid, a cosmic centrifuge, whipping ice and rock into an odd, flattened form. Its length is about 2,000 kilometers, but its narrowest dimension is nearly half that. Imagine Earth spinning so quickly it bulged into a flying saucer. That's Haumea. In 2017, scientists made a shocking discovery. While observing a stellar occultation, where Haumea passed in front of a distant star, astronomers detected something never seen before around a trans-Neptunian object. A ring. Yes, Haumea has a ring system. It orbits close to the planet's equator, about 2,300 kilometers from the surface. Thin, narrow, reflective, and completely unexpected. Before this, rings were reserved for the gas giants, then Chariklo, then Chiron. But Haumea? No one saw that coming. The ring makes even more questions come up. How did it come together? Is it the result of a crash in the past? Was it thrown off the surface of Haumea by its fast spin? Is it stable for a long time, or are we catching it as it starts to fall apart? Whatever the answer, one thing is clear. Haumea isn't just another frozen rock. It's a system, complete with moons, a ring, and a rotation that keeps everything in motion. Yes, moons. 2 of them. Hi'iaka is the larger, named after a Hawaiian goddess just like Haumea herself. It's icy, bright, and follows a stable orbit. The smaller one, Namaka, is harder to observe, darker, slower, wobbling in a more chaotic path. Their presence helps scientists study Haumea's mass, density, and interior, which, by the way, is probably a rocky core wrapped in crystalline water ice. That surface composition is rare for Kuiper Belt objects, which are typically covered in darker, more carbon-rich compounds. Haumea reflects more sunlight than expected. Some even say it sparkles. How does that ice stay so cool? Cryovolcanism is one idea. This means that Haumea could have resurfaced with new ice, either because of heat inside the volcano or impacts. Its spin is linked to another idea. The centrifugal force may help melt old ice and reveal new, clean ice. Also, since we're talking about collisions, there's strong evidence that Haumea was once broken. Its rapid rotation and family of nearby objects suggest that Haumea may have been hit by a large body long ago, splintering its crust and flinging debris into orbit. Those fragments became its moons, its ring, and maybe even other Kuiper Belt objects that now follow similar orbits. The idea isn't perfect, but Haumea doesn't give up its secrets easily, just like a good mystery should. This is true even for the way we see it, which is mostly through Hubble or artists' impressions based on occultation data. We don't have any close-ups. No spaceship has been there. The picture is still being put together from shadows and light reflections, but the pieces are beginning to fit together. In combined pictures, Haumea is a glowing blur, and its moons often circle around it like obedient servants. It's shown spinning quickly in pictures, with its ring shining like a frozen hula hoop in the moonlight. But Haumea is really different from everything else in our system. A small planet that wears a ring, spins like a dancer, and has icy moons could be hiding secrets from the early days of the solar system when it was very chaotic. It's not really big, not the smartest, not even the most well-known, but it could be the strangest. Makem, the shadowed pearl of the Kuiper Belt. It is very cold in the Kuiper Belt. The sun is a pale, faraway lamp, and there is a lot of quiet. There is a world called Makem that is both bright and dark. Discovered in 2005 and officially recognized as a dwarf planet in 2008, Makem doesn't scream for attention like Pluto or dazzle with rings like Haumea. But this remote object, smaller than Earth's moon, is one of the most enigmatic worlds in the solar system. Like its mythic counterpart, Makem hides more than it shows. Its name comes from the Rapa Nui god of fertility and creation. Makeup looks beautiful to the naked eye. This object is one of the brightest ever found in the Kuiper Belt. It reflects about 60% of the sunlight that hits it, which is almost as much as snow does right after it falls. Early drawings of it showed it as a sparkling frosty rock covered in methane and nitrogen ice. But then came the first surprise: a moon. In 2016, the Hubble Space Telescope detected a tiny companion just 100 miles across, nicknamed MK2. Seen as a faint dot next to Makem, this moon seemed to orbit very close and very dark. MK2 is almost unnoticeable because it only reflects about 4% of the light that hits it, even though Makem shines. That's like black dark, a moon made of shadows going around a frozen body. This made me think about something very important. If Makem can shine so brightly, then why doesn't its moon? It seemed to say that Makem's genius isn't all the same, that yearly frost or short-term ice covers may give it some of its shine. Those could fade away over time, maybe even leaving behind darker areas like the moon's shade. Makem is cold, about 240 degrees Celsius, and that brutal temperature keeps methane and nitrogen frozen solid. But as the dwarf planet orbits the Sun once every 310 Earth years, some scientists believe its surface breathes, cycling gases on and off. That breath, in turn, might drive a temporary atmosphere, forming when Makem is closest to the Sun and collapsing as it moves away. If you believe in this seasonal atmosphere idea, Makem is one of a kind. It changes its own air. It's been compared to Pluto because it's about the same size and makeup, but unlike Pluto, Makem doesn't have a clear haze, a proven atmosphere, or well-mapped surface markings. In terms of reflection, it's bright, but in terms of data, it's dark. In one of Hubble's composite images, Makem and MK2 drift through the Kuiper Belt like a mismatched pair. The primary glows, the moon skulks in shadow. The contrast is stark and haunting. Meanwhile, ground-based telescopes like ESO's Very Large Telescope in Chile have helped refine our understanding of Makem's surface. They show signatures of methane ice with hints of ethane and tholins, complex organic molecules formed from radiation. These tholins may be responsible for subtle reddish hues, staining parts of the surface with a tint of age and chemical history. Still, we have no spacecraft photos. No high-resolution maps, no landers, no orbiters. What we know comes from reflected sunlight, stellar occultations, and the occasional infrared ping. But even that limited data has revealed a world that doesn't quite behave like we thought it should. In fact, Make's very density is still under debate. Estimates suggest it's composed of a mix of rock and ice, but the exact proportions? Unknown. Its internal structure? Unmeasured. Its rotation speed? Only loosely constrained, somewhere around 7.7 hours, but maybe less, or more. What we do know is this. Make rotates quickly enough to affect its surface temperatures. As it spins, parts of it heat and cool by just a few degrees, enough perhaps to cause thin frosts to migrate across its surface like whispers of fog. What shape does it have? Perhaps oblong, could be rounded, might be lumpy. The truth is still far away, billions of kilometers away, until we get closer. Still, Make is an important object for studying dwarf planets, even though it is very mysterious. We learned that light doesn't always mean ease of use, that the moon can be black and the star it orbits can be white. This kind of environment can change over time. Eris, the distant rival that dethroned Pluto. When a telescope looked into the very edge of the solar system in 2005, it found something that changed everything. Pluto was not as bright as it was. It was farther away. It was bigger. It was even called the 10th planet for a short time. But that icy, faraway and reflected object did more than just make science books more interesting. The idea of what a planet is had to be changed because of it. Its name comes from the Greek goddess of war, Eris. It made sense, given the confusion it caused. Discovered by a team led by Mike Brown at Palomar Observatory, Eris is a dwarf planet that orbits nearly 3 times farther from the Sun than Pluto, a staggering 96 astronomical units at its farthest point. That's over 14 billion kilometers away. From that distance, the Sun is just another bright star. And yet, Eris glows. That glow comes from its surface, which is covered in a reflective frost, likely made of nitrogen and methane ices. The same frosty coating we see on Pluto, but even cleaner and more pristine. In fact, Eris reflects 96% of the sunlight that reaches it, making it one of the brightest known objects in the Kuiper Belt. Images taken with a telescope show Eris as a bright dot. But in 2006, Hubble took a closer look and found something else. A moon. It is called Dysnomia, which comes from the name of a Greek goddess who was the daughter of Eris and the goddess of anarchy. Dysnomia is a small dark body that is about 700 kilometers across. It helped scientists do an important thing. It helped them weigh Eris. By watching the moon's orbit, researchers were able to calculate Eris's mass. And to everyone's surprise, it turned out to be 27% more massive than Pluto, even though its diameter is nearly the same. That means Eris is denser, likely with more rock beneath its icy crust. The discovery of Eris and its moon was so disruptive that it triggered a major decision. The International Astronomical Union, IAU, created a new category, dwarf planet, and Pluto was reclassified. Eris wasn't just a distant rock, it was the trigger point for one of astronomy's biggest debates. We have never sent a spaceship there. We don't have any close-up pictures. The only things we know are from telescopes on Earth and models of orbits. We know just enough to want to know more. For example, Eris's orbit is very irregular and takes 557 Earth years to finish. For hundreds of years, it has fallen into the deepest parts of the solar system. But one day, it will swing back closer to the Sun than Neptune. When it does, scientists suspect that Eris could grow a temporary atmosphere, just like Pluto. As its icy surface warms, nitrogen and methane could vaporize and form a thin envelope around the dwarf planet, only to freeze again as it retreats. This cyclical atmosphere would rise and fall over hundreds of years, a breath as slow as a civilization. And the surface? Smooth, white, and likely frosted with frozen methane, but also hard, possibly crystalline from the cold. This surface may be one of the oldest and most unweathered in the solar system. Nothing stirs there. No sunlight softens it. No wind reshapes it. In pictures made by artists, Eris looks pale and shiny, and Dysnomia's orbit in the distance sometimes casts a shadow on it. It seems far away, not touchable, but also very grand. In a Hubble mosaic from 2006, the two bodies are easy to see. Eris is in the middle, and Dysnomia is at 9 o'clock, Their huge difference in brightness is easy to see. Dysnomia moves like a sooty spark, while Eris shines like a pearl. That difference in light could mean more than just ice on the top. It might help us understand how these things came to be. For example, dysnomia could be a piece of Eris that was made by a big impact that changed its shape a long time ago, similar to how Earth's moon may have been formed. Quaoar, the rule-breaking ring-bearer of the outer solar system. Out beyond Neptune, where the sun casts only the faintest shadows, lies a world that shouldn't exist the way it does, or at least its ring shouldn't. This is Quaoar, a dwarf planet discovered in 2002 and named after the creator god of the Tongva people, the indigenous tribe of the Los Angeles Basin. At first glance, Quaoar seemed like just another icy relic of the Kuiper Belt, roughly 1,100 kilometers in diameter, a quarter the size of Earth's moon, orbiting about 43 times farther from the Sun than Earth. Yet, in early 2023, Quaoar did something that scientists had no idea it would do. It was found to have a ring around it, a thin, faint, icy halo. That wasn't shocking on its own. Some small things in the solar system like Chariklo, Haumea, and even some centaurs now have rings around them. But Quaoar's ring wasn't like the others. It broke the rules. You see, rings aren't supposed to survive at a distance from their planet that exceeds what's called the Roche limit, the gravitational boundary where a planet's pull can shred a moon into pieces, forming rings. Outside of that boundary, material typically clumps together and forms moons instead. But Quaoar's ring, it sits way outside its Roche limit. It shouldn't exist. And yet, there it is, stable, complete, and defiant. This strange ring was discovered not by direct imaging, but by stellar occultation. When Quaoar passed in front of a distant star, and scientists noticed the light dimmed twice briefly, before and after the main occultation. These pre-dips were caused by the ring material blocking starlight. Why isn't that stuff turning into a moon? What's the deal with it being so far below Quaoar's surface? And why doesn't it fall down? Theories are still being made. Some people think that sticky ice particles and cold temperatures might stop the gathering that is needed to make a moon. Some people say that Quaoar's close moon Waywatt may be causing secret resonances or gravitational pulls. Waywatt, named after the son of Quaoar in Tongva mythology, is a tiny, irregular satellite, about 170 kilometers across. It orbits in a quirky elliptical path and might play a key role in stirring or stabilizing the ring material, or possibly contributing to it via past impacts or collisions. In artist renderings, Quaoar is imagined as a dusky, icy sphere, dotted with impact craters and ringed with a halo of dust and ice. The ring, sharp and thin, floats like a halo just above its equator, tilted slightly against the background stars. But don't get it wrong, Quaoar is not a frozen rock. It's very complicated geologically. Spectral research shows that the surface is made up of water ice, methane ice, and ammonia hydrates, all of which have been formed by cosmic weathering over millions of years. The presence of ammonia suggests that cryovolcanic activity or internal heating happened in the past. This means that the world was once warm enough for processes going on inside to reach the surface. And yet, despite all that activity, Quaoar is barely visible from Earth. At its distance, it reflects just enough sunlight to be detected as a dim moving speck. Even the Hubble Space Telescope can only capture it as a blurry object, accompanied by its faint satellite. It's not just Quaoar's size, ring, or strange moon that makes it so interesting, because it goes against what you expect. It makes us think about how time, gravity, and ice work together in the outer solar system. Rings can live in places they shouldn't be able to. That there are no hard and fast rules, not even in the well-ordered math of orbital dynamics. This may not be the only case either. Gong, the red giant of the deep freeze. At the edge of the solar system, where light fades and time slows, drifts a world named after a god of floods and cosmic mischief. Its name is Gong, a dwarf planet as strange as its mythological namesake. a celestial body both massive and mysterious, painted in deep red and wrapped in silence. Discovered in 2007 and officially named in 2020, Gong Gong is one of the largest known trans-Neptunian objects. With a diameter of approximately 1,230 kilometers, it rivals Pluto's smaller cousins in size. But what sets Gong Gong apart is how much it doesn't behave like the others. Most distant objects have dull grey or icy white hues. Gong Gong is blood red, rich in complex radiation-processed molecules called tholins, which stain its icy surface like cosmic rust. These tholins form when ultraviolet sunlight and charged particles hit methane and other hydrocarbons, rearranging them into dark reddish gunk. That suggests a methane-rich surface, or at least methane ice once present, enough to leave a permanent chemical mark. This coloration links Gong Gong to a handful of other red Kuiper Belt objects, possibly members of a distinct population of ice-rock hybrids, more organic-rich than typical outer solar system bodies. Gong Gong rotates incredibly slowly, once every 22 hours, which is a full planetary day. For an object this size, that's sluggish. And that sluggish spin had scientists scratching their heads until they discovered its hidden companion, a moon. Enter Xiangliu, named after a snake-like water monster from Chinese mythology who served Gong Gong. In 2010, the Hubble Space Telescope spotted this faint moon orbiting the dwarf planet. While barely visible, Xiangliu holds the key to understanding Gong Gong's sluggishness. The leading theory? Tidal interactions. Just as Earth's moon slows our planet's rotation over time, Xiangliu is thought to be gradually breaking Gong Gong, locking the system into a slow orbital rhythm. This tidal dance could eventually lead to synchronous rotation, where Gong Gong always shows the same face to Xiangliu, just as our moon does to us. The world is now hot and cold, a slow spin, a tiny moon that causes trouble. But that's not the end. The path that Gong Gong takes around the Sun is one of the longest and curved of any small planet. It goes from 35 to 100 astronomical units, AU, from the Sun, which is a very strange path. That's more than 9 billion kilometers away. It takes more than 550 years for one orbit to finish. At some points in its journey, Gong Gong gets closer to the Sun than Eris. It then swings back out past Pluto and into the cold twilight of the outer solar system. It's just one traveler, teetering on the edge of gravity pull, possibly being pulled by invisible forces or old crashes. Some astronomers have even speculated that Gong Gong's peculiar path might help track the elusive Planet 9, a theoretical super-Earth that could be lurking in the darkness. Objects like Gong Gong might be subtly shaped by its pull, drifting like breadcrumbs through space. And while we haven't seen Gong Gong up close, composite images from Hubble and infrared data from ground-based observatories give us a haunting glimpse. In one frame, it appears as a reddish speck accompanied by a fainter dot, Xiangliu, caught mid-orbit. Another shows its rough orbit traced across the solar system, a looping arc that dips, twists and climbs like a roller coaster of gravity and ice. We don't know if Gong Gong has an atmosphere yet, or seas below the top, or cold mountains, but we know it's very big and that it probably has a hard core and an icy covering. Its density points to a layered interior that may have been warm enough for short geological action in the past, or it may still be locked deep inside, waiting for a future mission to find it. Its ringless shape, red color, and tidal locking all point to a history of crashes and reshaping, a world that wasn't always calm, but was formed by cosmic chaos. The moon, our familiar stranger. Years and years we've looked at it. They wrote songs about it, used it to measure time. We walked on it. Yet the moon, which is the only natural satellite of Earth, still hides many things. At only about 384,000 kilometers away, it's the nearest heavenly body to Earth. However, its surface is marked by the signs of the cosmic past, and most of its far side has not yet been explored by humans. With all the new information coming in from NASA, China, and private missions, we can see how much we still need to learn about this old partner on Earth's trip. Start with one of the most awe-inspiring perspectives ever captured. Earthrise, photographed by astronaut Michael Collins during Apollo 11's return journey. It's the only Earthrise image ever taken after trans-Earth injection, showing our fragile, glowing world rising over the Moon's barren horizon. That's when Earth seems small, blue, open to harm. The Moon? It was huge, grey and still. The shot changed the way people thought about themselves. But if you zoom in, the Moon changes again. Some of the most detailed features on the Moon's surface have been caught by high-resolution pictures from the Lunar Reconnaissance Orbiter, LRO. One of these is a dramatic oblique view of the top area of Tycho crater's central peak. A huge boulder 120 meters wide sits near the peak like a memorial in one amazing picture. It was formed by a violent impact more than 100 million years ago. The crater itself is sharp-edged, young by lunar standards, and so prominent you can see its rays from Earth. But that boulder? That boulder tells a story of resilience. It's been sitting there for eons, untouched, unmoved, a cosmic relic baked in sunlight and silence. Yet the Moon isn't uniform. What we see from Earth, the near side, is just half the story. The far side, revealed in full by LRO's orthographic projection map, shows an entirely different landscape, more cratered, rugged, and ancient. Unlike the smooth Maria, lava plains that dominate the near side, the far side is a patchwork of highlands and deep impact scars, untouched by the volcanic flows that once smoothed out its sibling hemisphere. No one has ever walked on that land. No robot has gone across those faraway rough areas yet. Scientists are still trying to figure out why the two halves of the Moon are so different. Some ideas say that the Earth's gravitational pull affected the process of cooling inside. Others point to a huge impact in the Moon's early history, possibly a twin impactor that changed the shape of one side but not the other. The story gets even more complicated when we dig deeper. Data from NASA's Grail mission revealed that the Moon's crust is surprisingly thin and riddled with fractures. Underneath, there may even be pockets of molten rock, especially near the core. Could volcanic activity, long thought extinct, still be smoldering in places we haven't yet explored? Add to that the recent discovery of water molecules in sunlit regions, not just frozen in shadowy craters, but bonded to lunar soil across much of the surface. It's not enough to drink, yet, but it's enough to change how we view sustainability for future lunar colonies. From Apollo to Artemis, we're returning. But this time, we're not just planting flags, we're planning to stay. New missions are targeting Tycho, the lunar South Pole, and lava tubes, underground caves created by ancient lava flows that might serve as shelters for future astronauts. China's Chang'e missions have already brought back new samples, and private companies are aiming for soft landings within the decade. Phobos, the doomed moon of Mars. It looks bad. It's not a circle. It won't last long. The biggest moon of Mars, Phobos, isn't very pretty, but it makes up for it in mystery and cosmic tragedy. Phobos is about 27 kilometers across and looks more like a potato than a sphere. It's a rough, jacked-up piece of rock that's falling slowly toward its parent planet. Its orbit is only 6,000 kilometers above the surface of Mars. It goes around the planet 3 times a day, which is faster than Mars spins. Every orbit, Phobos creeps closer. Every year, it drops about 2 centimeters. At this rate, in 30 to 50 million years, it will either crash into Mars or break apart into a ring of debris. It's a death sentence written in orbital mechanics. Take the Stickney crater, the most dominant feature on Phobos' surface. Captured in a heavily saturated false-color image by the Mars Reconnaissance Orbiter, MRO, in 2008, Stickney spans nearly half the Moon's width. A wound so large that it nearly shattered the Moon when it formed. Within Stickney lies a smaller impact scar, Limtok, and around the edges you'll see grooved lines, not just from this crater, but from the Moon's fractured interior, the result of internal stress from repeated Martian tidal forces. Phobos goes around more than just Mars. It's pulling it apart. If you look more closely, a geomorphological picture taken by the High-Resolution Stereo Camera, HRSC, on board the Mars Express mission shows a surface with pits, grooves, and landslides that looks like broken sidewalk. Some of these traits might be caused by dust slowly sliding downhill because of Mars's pull. Others are probably the marks of many collisions in a world with no atmosphere. Parts of Phobos's surface appear unusually soft and porous, raising the question of whether it's a rubble pile, a loose collection of rocks held together by gravity rather than a solid body. That would explain why it's so easily shaped, and why it hasn't broken apart yet under Mars's tidal influence. On February 8, 2024, NASA's Perseverance rover looked up from Jezero crater and captured a breathtaking silhouette, Phobos passing in front of the Sun. In the image, Phobos appears as a ragged bite taken out of the solar disk, casting a shadow like a ghost over Mars's surface. It's not a total eclipse, the moon's too small, but the event is still a stunning celestial ballet, a robotic witness to a fleeting moment of alignment on another world. Japan's space agency JAXA is currently preparing its Martian Moons Exploration (MMX) mission, which will visit both Phobos and Deimos. But Phobos is the main target. MMX will land, collect samples, and return them to Earth, potentially revealing the moon's true origin. Because we still don't know where Phobos came from. Some people think it's a rock that was caught from the outer solar system. Others say it was made from pieces of Mars that were thrown up by a huge impact a long time ago. There may be an end to this argument for good with the MMX project. It will also help explain why Phobos is so different from everything else in the Martian system. Some new concept art and combined images show Phobos, a dark rock racing just above Mars's surface, crossing the red skies of the planet. It's creepy, beautiful, and lost. Deimos, the quiet companion of Mars. If Phobos is the warrior who is about to die, then Deimos is the one who is watching. Deimos, Mars's smallest moon, is just around 12 kilometers wide, which is not much bigger than a city. People frequently forget about it because its bigger brother is so much more interesting. Deimos isn't very big or exciting, yet it is quite mysterious and has one of the most gorgeous orbits in the solar system. Deimos orbits Mars at a distance of about 23,500 kilometers, far beyond Phobos, and takes roughly 30.3 hours to complete a single orbit, just longer than a Martian day. That means, unlike Phobos, which races across the sky multiple times a day, Deimos moves slowly, rising and setting, much like the moon does on Earth. To observers on the Martian surface, Deimos appears as a bright star gliding across the dusk, and for the first time in history, we're beginning to see it from up close. On March 12, 2025, the ESA's Eris spacecraft performed a close flyby of Deimos and captured a stunning infrared silhouette of the moon against the red Martian disk. The image is ghostly and ethereal, the moon's light blue outline glowing against the warm planet below. It's a reminder of just how tiny and fragile Deimos really is, a grain of rock drifting over a giant. A separate composite image, built from photographs taken by the Emirates Mars mission, revealed the moon's pitted surface in unprecedented clarity. From about 100 kilometers away, the probe recorded Deimos's gentle curves, its cratered plains, and the way sunlight skims its jagged edges. One image, now iconic, shows Mars looming beneath Deimos, its thin atmosphere giving off a soft gradient glow, while the tiny moon floats in the foreground like a spacecraft itself. Unlike Phobos, which is being torn apart by Mars's gravity, Deimos orbits just far enough to be stable. Its path is nearly circular, and its distance from Mars means it's not at risk of crashing or disintegrating anytime soon. But that difference has made people wonder. Both Deimos and Phobos have strange shapes. They look more like asteroids than moons. And for many years, the most popular idea was that both moons were trapped comets that were drawn to Mars by its gravity. But new information has made that story more complex. Some researchers now believe Deimos may have formed from debris after a massive impact on Mars, just like Earth's moon. That debris could have formed a ring around the planet that slowly coalesced into two moons, If true, that would mean Deimos isn't a foreign body at all, but a child of Mars. To confirm this, scientists will need to sample its surface, and missions like Japan's MMX aim to do exactly that. By comparing the composition of Phobos and Deimos and studying their orbits and densities, we may finally answer one of the oldest mysteries in Martian science. Where did these moons come from? Deimos's surface is gentler than Phobos's, with fewer fractures and less dramatic grooves. It still bears scars, craters, pits, and signs of ancient impacts, but its overall appearance is softer, dustier, more worn down by billions of years of micrometeorite erosion. Larger moons like Europa and Titan make people feel more awed. It doesn't have any volcanoes, geysers, or oceans that aren't visible. But Deimos gives us a different point of view. In artists' ideas and new pictures, Deimos is seen as a shadow above Mars, looking like a small rock moving in front of a red giant. There is no telescope on Earth that could ever catch that moment. A reflection that every moon, no matter how small, plays a part in the big picture of the universe. And while Phobos may one day shatter, Deimos will remain, a lasting monument to the ancient, violent past of the solar system, and perhaps a future landing site, a place to look back at Mars and study it from a serene, stable platform. Io, the moon that never sleeps. If the moon is a silent friend and Deimos is a floating ghost, then Io is the solar system's screaming nerve, shaking, exploding, and changing shape all the time. The most volcanically active object we've ever found is a moon in orbit around Jupiter that looks like it's in a lot of pain. Io is not only alive, it's angry. It has more than 400 active volcanoes, and some of them are sending lava hundreds of kilometers into space. Discovered in 1610 by Galileo Galilei, Io was the first of Jupiter's major moons ever observed. At first it seemed unremarkable, just another speck orbiting the gas giant, but that all changed in 1979 when NASA's Voyager 1 performed its historic flyby. What the spacecraft saw shocked scientists. Io was pockmarked with volcanoes, vast sulfur plains, and towering mountains. But more than that, it was erupting. At that very moment, Voyager captured an image of a massive volcanic plume bursting 300 kilometers above the surface, the first direct observation of an active volcano outside Earth. Today, our best views come from NASA's Juno spacecraft, currently in orbit around Jupiter. On February 3, 2024, Juno captured an astonishing close-up of Io from just 3,800 kilometers away, revealing two volcanic plumes rising above the horizon, silhouetted against space. In the photo, you can see the edge of Io's curved surface glowing from the heat of freshly erupted lava, with the plumes bursting upward like geysers of liquid flame. Io is constantly erupting, with lava lakes, flowing rivers of molten rock, and ash clouds that paint the surface in surreal colors. In recent infrared images captured from about 80,000 kilometers away, Io's night side glows with hundreds of volcanic hotspots. Some are small, others stretch for kilometers, seething calderas that never cool. In one composite image, Jupiter shine illuminates Io's dark side. Sunlight reflecting off Jupiter itself lights up the shadowed terrain, revealing a world scorched and blistered by internal forces. But where does all this heat come from? The answer is tidal flexing. Io is locked in a gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. This orbital resonance causes immense tidal forces that stretch and squeeze Io like a rubber ball. It's like being caught in a planetary vice, with gravity pulling at your insides from three sides. That friction heats Io's interior, melting rock into magma. Unlike Earth, where volcanic activity is driven by radioactive decay, Io's fury is purely mechanical, the result of being pulled and pummeled endlessly by gravity. Instead of smooth plains or icy fields, Io is covered in lava flows, collapsed calderas, and scarred mountains. Some mountains rise higher than Everest, but none are peaceful. They're the cracked, crumpled remnants of crust, twisted by tectonic madness. The colors of Io are just as strange. It looks yellow-orange in natural light, because sulfur and sulfur dioxide cover a lot of its surface. The scenery is stained with black, red, green and white spots from volcanic deposits, though, making it look like something from a surrealist picture. Some improved pictures of Io make it look like it is radioactive, because it is glowing with bright green and blood-red spots that look like wounds on a dead volcano. And yet, despite all this chaos, Io keeps orbiting Jupiter every 1.8 Earth days, faster than any other large moon in the solar system. As it orbits, it moves in and out of Jupiter's powerful magnetosphere, which causes further friction, electric charge buildup, and plasma interactions. In fact, Io actually contributes to Jupiter's auroras. Volcanic gases ejected from its surface become ionized and trapped in Jupiter's magnetic field, forming a vast plasma torus around the planet. These ions accelerate along magnetic field lines, slam into Jupiter's atmosphere, and light up the polar regions with incredible auroras. Io literally electrifies the giant. Despite its violence, Io has no atmosphere to speak of, just a tenuous envelope of sulfur dioxide, quickly stripped away by space. There's no air, no water, and no chance for life as we know it. But in many ways, Io is alive in a different sense, geologically, electrically, and visually. Europa, the ocean moon that may harbor life. If Io is like the fire of the solar system, Europa is like its deep, icy breath. It is cold, cracked, and hides one of the most intriguing secrets in planetary science, a huge ocean of liquid water beneath its frozen shell. Europa is one of Jupiter's 4 Galilean moons. It is about 90% the size of Earth's moon, but the way it looks is very different. The world is broken up and made of ice. It is pale and has twisted lines that don't come from mountain ranges or river valleys, but from deep cracks in the ice. These cracks go on for thousands of kilometers and cross each other like veins. What's below, though, is even more interesting. In 2014, the Hubble Space Telescope made a shocking discovery. As Europa passed in front of Jupiter, Hubble's Space Telescope Imaging Spectrograph, STIS, detected subtle ultraviolet changes on Europa's limb, signs of water vapor plumes, erupting from the surface and rising over 100 miles high. That plume, pictured in a now iconic composite silhouette, hinted that Europa isn't just a block of ice. It's a geologically active moon, venting water from its interior ocean into space. Take that in. There is a moon with geysers that shoot stuff out into space from an ocean below. Everything has changed, because Europa might have more than just an ocean below the surface. It might also have the right conditions for life. Scientists think that the ocean below Europa's icy crust could be 60 to 150 kilometers deep and hold twice as much water as all of Earth's seas put together. And because that ocean is right next to a hard core, the warm tides from Jupiter's gravity could power hydrothermal vents on the ocean floor, just like the ones on Earth that are full of life even when it's dark. We've never seen that ocean directly, but images taken by the Galileo spacecraft during its flybys in the late 1990s gave us important clues. In a stunning image taken on June 27, 1996, the icy surface appears shattered, full of ridges, blocks, and smooth plains. Some areas look like ice flows in Earth's polar seas, pushed around by slow subsurface currents and then refrozen. Others show chaotic terrain, where blocks of crust have broken apart, rotated, and refrozen, suggesting a slushy or even liquid layer below. That surface movement, even if subtle, implies dynamic interaction between the crust and the ocean beneath. Europa's color is largely a mix of whites, blues, and rusty browns. The blue hints at cleaner ice, possibly from recent resurfacing. The browns, especially in fractured zones, suggest the presence of salts, sulfur compounds, and possibly organic materials brought up from the ocean and baked by radiation. In one haunting artist's concept, Europa's crust is rendered in translucent ice, with glowing blue fractures and an ocean teeming with alien biology lurking below. It's pure speculation, but not without scientific footing. The idea that life could exist in Europa's ocean has grown from sci-fi fantasy into serious research. If microbial ecosystems can survive near volcanic vents on Earth, completely independent of sunlight, why not Europa? This is why NASA's Europa Clipper project, which will begin in 2024, is so important. Clipper won't stop on Europa, but it will go around Jupiter and do about 50 close flybys of it, using ground-penetrating radar, magnetometers, and high-resolution cameras to scan the surface. To find out what's going on with the plume, the probe will look for signs of plume activity and measure the thickness of the ice shell. If it goes through one, it might be able to take samples from the ocean without having to make a single hole. That would be history-making, and we may not have to wait too long. Some recent Hubble data and reanalyzed Galileo measurements suggest plumes may be common, not rare. They could vent more regularly than we thought, forming a gateway to the hidden sea. In anticipation, scientists are preparing analog missions in Earth's polar regions, deploying mini-submarines and cryobots into frozen lakes and under Antarctic ice to simulate what Europa exploration might one day look like. For now, we have our eyes and our telescopes. The latest observations from both Earth and orbit continue to hint at a living system beneath the ice. In every crack, every plume, and every resurfaced patch, there's the possibility that something, even the tiniest microbe, might be swimming beneath. Ganymede, the giant moon, with a hidden sea and a magnetic heart. Mercury is not as big as it is. There is a magnetic field around it. It could also hide more water than Earth does. Giant Ganymede is the biggest moon in our solar system. It circles Jupiter and is a real planet heavyweight. Ganymede is so big, 5,268 kilometers, 3,273 miles across, that it might have been called its own planet if it went around the Sun instead of Jupiter. But size isn't everything. Thanks to recent missions and new imaging technologies, Ganymede is shedding its reputation as just another icy moon. It's emerging as one of the most complex and intriguing worlds in our solar system, with ridges, grooves, oceans, and auroras, all layered into one frozen shell. Images taken by NASA's Juno spacecraft during its June 7, 2021 flyby brought the surface of Ganymede into sharp focus. In a breathtaking image captured by Juno Makem, we see bright and dark terrain sliced by massive fault lines. These are not random cracks. They are tectonic scars, etched by the shifting of Ganymede's icy crust over time. The dark regions are ancient, heavily cratered, and scarred by impacts. The bright regions, in contrast, are younger and grooved, carved by icy tectonics that suggest a restless crust, shaped by heat from within. Some of these grooves stretch thousands of kilometers across the surface in massive curved arcs. The geology here is unique, not shaped by flowing water or molten lava, but by slushy ice moving beneath a rigid shell. Some areas show what look like ice floods, where frozen material once flowed like glaciers before solidifying. But underneath that crust, things get even more dramatic. Ganymede is believed to contain a global subsurface ocean, buried beneath a thick ice shell. This ocean could be 100 kilometers deep, more than 10 times the depth of Earth's Mariana Trench, and may be sandwiched between layers of ice and rock. Some models even suggest multiple ocean layers, stacked between ice sheets like a cosmic lasagna. This ocean isn't directly observable, but we know it's there thanks to magnetic readings from both Galileo and Hubble. Ganymede is the only moon with a self-generated magnetic field, produced by a liquid iron or iron sulfide core at its center, a dynamo similar to Earth's. But here's where it gets really strange. Ganymede's magnetic field interacts with Jupiter's enormous magnetosphere, creating auroras. That's right, Ganymede has northern and southern lights. Hubble's ultraviolet imaging showed auroral belts oscillating around the moon's poles. And when scientists noticed that these belts were offset in strange ways, it suggested that a conductive ocean, salty and massive, was disrupting the magnetic field from beneath. In one of the most dramatic pieces of evidence to date, a chart from Hubble data visualizes this auroral wobble, a subtle but powerful indicator that there's a salty liquid ocean interacting with the moon's magnetic shell. That ocean may be locked beneath 150 kilometers of ice, but it's very real and very large. In fact, it may contain more water than all of Earth's oceans combined, making Ganymede a top candidate in the search for extraterrestrial life. And unlike Europa, Ganymede's surface is older and thicker, meaning it may be harder to reach that ocean. But it also means geological activity may have persisted longer than we thought, potentially creating thermal vents or chemical gradients capable of supporting microbial ecosystems. In 2034, the European Space Agency's JUICE, Jupiter Icy Moons Explorer, will enter orbit around Ganymede, making it the first spacecraft ever to do so. It will conduct detailed surface mapping, subsurface radar scans, and magnetosphere studies to understand the Moon's geology and internal ocean. NASA's Europa Clipper will also fly by Ganymede during its Jupiter system tour, offering complementary data that could help us understand how all these icy moons evolved together, and why Ganymede in particular grew so massive and magnetically active. In the meantime, citizen scientists and NASA imaging specialists continue processing JunoCam images to bring out Ganymede's hidden beauty. From false color mosaics of icy ridges to shadowed craters and shimmering ice fields. In one enhanced photo, the fractured terrain glows with purples and blues, while another reveals an expansive view of the Galileo Regio, a huge, dark region thought to be a remnant of early resurfacing events, possibly from cryovolcanism. Callisto, the ancient survivor of the solar system. If Jupiter's moons were a family, Callisto would be the oldest. It is scarred, tough, and lies a lot. Callisto might not look as interesting at first glance as its brothers. It doesn't have the volcanic outbursts of Io, the icy plumes of Europa, or the magnetic heart of Ganymede. Callisto, on the other hand, shows us something quieter but just as interesting. Its craters freeze 4 billion years of stellar history. Callisto is the second largest moon of Jupiter and the third largest in the solar system, just slightly smaller than Mercury. It orbits farther out than the other Galilean moons, some 1.8 million kilometers from Jupiter, placing it just outside the most intense zone of Jupiter's radiation. That distance has preserved its surface in an almost primordial state. From afar, Callisto looks like a heavily cratered ice-rock hybrid, grey and brown, like a weathered stone. But thanks to spacecraft like Voyager, Galileo, and advanced imaging by Hubble, we've seen just how textured and scientifically rich this moon really is. The Valhalla impact structure, which covers a huge part of Callisto's northern hemisphere, is one of the most interesting features. Valhalla is shown in a detailed Galileo mosaic as a bright center ringed by rings that move in and out of each other like waves in a frozen pond. The biggest ring is over 4,000 kilometers across. This spread effect wasn't just a chance meeting. It was an event that changed the world. Researchers think that the bullseye-shaped pattern was made when the impact waves went through a soft or partly wet layer below the surface. It's one of the strongest signs that Callisto may have been warm inside, and it may still be. The moon's entire surface is a canvas of craters, more densely packed than any other object in the solar system. These craters tell a story of survival, of a world that has not been resurfaced by lava, tectonics, or erosion for billions of years. Unlike Europa or Ganymede, Callisto's crust is stable and inert. Every impact scar, every ridge, every gouge has been preserved like a fossil in ice. But don't think that silence means it's easy. Something surprising is hidden beneath that old surface. As Galileo flew by Callisto, its magnetometer picked up generated magnetic fields, which suggests that there is an electrical layer below the surface. The best way to explain? A salty ocean that might be buried 100 to 150 kilometers deep in rock and ice. Yes, even Callisto might have an ocean. It wouldn't be as warm or accessible as Europa's, and there's no evidence yet of plumes or geysers. But if liquid water exists there, it raises tantalizing questions about habitability. Could simple life survive in such a cold, buried sea? Could ancient chemical gradients have persisted long enough to spark biology? Recent mapping efforts, including a composite map created in 2000 from Voyager and Galileo imagery, revealed subtle variations in elevation and albedo. Some regions are slightly smoother, with smaller craters and rolling terrain. These may indicate ancient landslides, cryovolcanic flows, or upwellings of softer material from below. Meanwhile, the southern hemisphere remains largely unmapped in high resolution, a frontier that future missions may target. The European JUICE mission, though primarily focused on Ganymede, will also perform 2 flybys of Callistoin the early 2030s, capturing new data with its powerful suite of instruments. Why Callisto? Because it might be a perfect place for human exploration. Unlike Europa or Io, Callisto lies outside Jupiter's most lethal radiation zones. In fact, NASA once proposed using Callisto as the site for a Jovian moon base, a station to study Jupiter, mine local resources, and stage missions to more dangerous environments. Its surface is stable, rich in water ice, and not subjected to constant volcanic or tectonic activity. Callisto could then be a safe place for people to stay in the Jupiter system. Even though it is cold and dry on top, it holds ancient secrets, and maybe the building blocks of life: ice, organic molecules, and rocks that have been kept for a very long time. In true color pictures, Callisto looks mostly dark and subdued, with a few bright spots where new ice has been formed by recent impacts. It's not bright like Io or shiny like Europa. It's humble, but that shame isn't real. Amalthea, the crimson shard that shadows Jupiter. Amalthea is different from all of Jupiter's moons, not because it is so big, but because it is so strange. It's not big, not right, red as blood. On top of that, it still casts a long shade over the giant it circles. Discovered in 1892 by American astronomer Edward Emerson Barnard, Amalthea was the first Jovian moon to be found after Galileo's famous discovery of the 4 large Galilean moons, nearly 3 centuries earlier. Unlike those icy giants, however, Amalthea is irregular, more asteroid than sphere. It stretches about 250 kilometers at its longest, yet only about 146 kilometers wide, resembling a tumbling boulder more than a balanced world. Orbiting a mere 181,000 kilometers from Jupiter, just above the planet's cloud tops, Amalthea moves fast, completing 1 lap every 12 hours. And in that tight orbit, it plays a remarkable visual trick. Captured in a stunning image by NASA's Juno spacecraft, Amalthea can be seen casting a long shadow across the swirling face of Jupiter. The image is surreal. A gas giant's banded clouds, vast and turbulent, suddenly darkened by the ragged silhouette of a red rock no larger than a major city. The elongated shape of the shadow, combined with Jupiter's immense curvature, gives the impression of a planetary eclipse in miniature. But Amalthea's color is just as strange. It is a deep red color, which isn't common for a moon so far from the Sun. Scientists think that this color might come from sulfur compounds and dust that fall to the surface of Amalthea from Io's strong volcano eruptions. Because Amalthea is constantly being hit by its more violent cousin, it looks like it has been burned, with ash stains and impact holes all over it. Images from NASA's Galileo mission revealed a surface blanketed in fine, dusty regolith, but also interrupted by massive craters and ridges. Some of its features, like the crater Pan and the ridge Mons Amalthea, suggest that despite its size, Amalthea has been struck hard over time, reshaping its jagged body again and again. Interestingly, Amalthea radiates more heat than it receives from the Sun, which was once a profound mystery. The best explanation? Jupiter's intense magnetic field and trapped radiation belts. Amalthea absorbs energetic particles as it orbits, which then heat its surface from the outside in. It's not enough to melt the moon, but it does give it a strange thermal glow, detectable in the infrared. Amalthea has a low density, less than that of water ice, suggesting it may be a porous mix of rock and ice, or even a rubble pile loosely held together by gravity. If that's true, it makes Amalthea highly fragile. A single major impact could tear it apart. Some scientists even suggest it's a captured object, possibly a Kuiper Belt relic dragged in during Jupiter's early gravitational upheavals. Supporting this fragility are images taken by the Galileo spacecraft in the 1990s, which revealed a heavily cratered, irregular surface, likely unable to resist tidal stresses for long. Yet somehow Amalthea endures. One of Jupiter's weak rings is made up of Amalthea. Little bits of dust are blasted off Jupiter's surface when micrometeorites hit it. They go into orbit around Jupiter, creating a thin, transparent ring system. Along with other inner moons like Thebe and Adrastea, Amalthea feeds the planet's dust halo. This is a ring that is too faint to see with the human eye, but can be clearly seen in infrared and ultraviolet light. It's like this tiny moon changes the look of the biggest world in our solar system just by being there, getting hit and leaking dust into space. Today, most images of Amalthea remain low resolution. Galileo gave us a handful of views during its flybys in the late 90s. Juno, though not focused on the small moons, occasionally captures Amalthea in the background of its spectacular Jovian portraits. From these glimpses, artists and scientists alike have rendered more detailed visuals. A red, ridged shard tumbling in sunlight, surrounded by invisible trails of dust, forever passing between Jupiter and the Sun. There are currently no planned missions targeting Amalthea specifically, but any future exploration of Jupiter's innermost moons will need to consider it, not only because of its orbital debris, but because of its position. Amalthea is one of the closest stable satellites to Jupiter, and any spacecraft getting too close would have to navigate intense radiation, gravitational tugs, and the high-velocity micrometeorite environment Amalthea helps sustain. Titan, Saturn's Earth-like mystery wrapped in orange haze. Among all the moons in the solar system, only one has a thick atmosphere. Only one has lakes, rivers, rain, and even seasons. That moon is Titan, the largest of Saturn's 145 known satellites, and possibly the most Earth-like world we've ever found. It's not Earth, though. Its rivers don't have water in them. The lakes there aren't full of life. The rain that comes from its clouds is liquid methane, not raindrops. Picture a thick orange sky that is covered in smoke. It looks like the sun is just a dim orange disk, like a flashlight tucked under a blanket. The ground below you is dark, muddy, and has drainage holes in it. What about way out there? The lakes are so still that they look like glass. They're not water, though. Titan is very cold, at minus 179 degrees Celsius, minus 290 degrees Fahrenheit, so the fuels that make them up, mostly methane and ethane, stay liquid. In 2005, the Huygens probe, part of the Cassini-Huygens mission, descended through Titan's atmosphere and landed, the first and only probe to land in the outer solar system. During its descent, it snapped 6 fisheye images that stunned the world. Through the haze, we saw valleys, channels, ridges, and what appeared to be a shoreline. And then, Huygens touched down. Its landing site, a frozen floodplain soaked with organic compounds. The probe survived just 90 minutes, but during that brief time, it captured audio, atmospheric data, and surface images. The ground appeared pebble-strewn, but those pebbles were water ice, rock-hard in the extreme cold. The scene was alien, and yet hauntingly familiar. Years later, Cassini would orbit Saturn and fly past Titan over 120 times, peering through the haze with infrared eyes and radar. One of the most stunning results was an infrared composite of Titan's North Pole, captured in 2015, showing glittering lakes and seas, the largest of which, Kraken Mare, is bigger than the Great Lakes combined. In radar scans, these bodies of liquid show up black as ink, perfectly smooth, indicating calm hydrocarbon seas with possible wave activity in some regions. Cassini even tried to spot sun glints off their surfaces, and it succeeded. Titan's weather system is seasonal, just like Earth's. As Saturn orbits the Sun every 29 years, Titan's poles trade winter and summer. Cassini watched this shift happen in real time, documenting shifting clouds, storms, and even possible rain events. One observation suggested a massive downpour had recently soaked Titan's equator, reshaping dunes and channels in ways we're still trying to understand. Titan is very interesting, but it's not just on the surface, it's what lies beneath. Like Europa and Ganymede, Titan is thought to have a large ocean below its surface. This ocean is made of salty water and is hidden by a layer of ice and hydrocarbons. Together, the gravity data Cassini gathered and the radar surface scans strongly suggest that this inner ocean may interact with Titan's surface or even explode in the form of cryovolcanic events. One image from Cassini's radar in 2007 revealed a strange dome-like formation that could be a cryovolcano, an ice-based analog to the lava volcanoes on Earth. If Titan's interior is active, it may allow complex chemistry to form at the boundary between ocean and rock, possibly even giving rise to primitive life. Titan is a prebiotic laboratory. Its thick nitrogen-methane atmosphere is chemically similar to Earth's ancient sky, before oxygen took over. Ultraviolet light from the sun breaks down methane high in the atmosphere, creating organic compounds, some of which fall as orange tholins, coating the landscape. In fact, Titan's dunes, vast sweeping ridges near the equator, aren't made of sand. They're made of carbon-rich particles, tiny, plastic-like grains that pile up into dark, alien deserts. It's this complex carbon-based chemistry that has scientists buzzing. While Titan's surface is likely too cold for life as we know it, its atmosphere and subsurface may hold the ingredients needed for exotic life forms, perhaps even ones based on liquid methane instead of water. In 2028, it plans to launch the Dragonfly mission, a rotorcraft lander designed to fly through Titan's skies, landing in multiple locations to study its dunes, weather, chemistry, and, possibly, signs of life. Dragonfly is set to arrive in 2034, and when it does, it will be the first time a flying drone explores another world. Enceladus, the little moon with a life-size secret. Enceladus, Saturn's moon, is only 500 kilometers, 310 miles, wide, so it shouldn't be able to do anything special. It's not big, it's cold, hard to see from Earth. But everything we thought we knew about this cold moon changed for good in 2005. Since Enceladus is still alive, in addition to exploding and breathing, it may even be home to living things. The revelation came from NASA's Cassini spacecraft, which spent 13 years orbiting Saturn. During one of its early flybys, Cassini spotted something strange coming from Enceladus's south pole. Faint ghostly plumes, barely perceptible in visible light. But in the right lighting, backlit by the sun, they lit up like firework fountains. These weren't just thin clouds of air. They were huge geysers that sent hundreds of kilometers of water mist, ice crystals, and biological molecules into space. And it wasn't a coincidence. The plumes came from long cracks in the ice that were called tiger stripes. These cracks are actually called sulci and have names like Damascus, Baghdad, Cairo, and Alexandria. A close-up picture from Cassini shows that these stripes are glowing with heat, which means that there is geothermal activity below. The material in these plumes doesn't just fall back onto the surface. Some of it escapes entirely, becoming part of Saturn's E-ring, a faint halo of ice and dust that Enceladus quietly maintains. This makes Enceladus the only body in the solar system known to contribute directly to a planetary ring. Cassini had the perfect tool for the job: instruments designed to fly through the plumes, analyze their composition, and send back the results. What it found changed our understanding of habitability forever. The plumes contained water vapor, salts, matching the chemical signature of an underground ocean, simple and complex organic compounds, and molecular hydrogen. On Earth, hydrogen vents deep in the ocean provide chemical energy for life, powering entire ecosystems around hydrothermal vents independent of sunlight. The presence of H2 in Enceladus's plumes strongly suggests that similar hydrothermal activity is happening on its ocean floor. Let's put this together. Enceladus has a whole ocean of liquid water that lies below a 20-30 kilometers thick layer of ice. That ocean touches a rocky core that may be hot. Chemical energy is made when water reacts with rocks. That energy is sent into space, where it carries biological chemicals and other signs that the space is habitable. This very small moon, which is smaller than England, is now one of the best places in our solar system to look for alien life. Images from Cassini's mole-wide map of Enceladus's topography show how uneven its icy shell is. Red marks the highlands, blue the lows, and the south polar region, where the tiger stripes lie, dips significantly, as if the ice is thinner or sagging above the ocean. This aligns with gravity data that suggests active upwelling of warm water and internal heat. Another dramatic close-up shows the tiger stripes themselves, lit obliquely by sunlight. Giant, gaping fissures, several hundred kilometers long and up to a kilometer wide. These are not random cracks. They pulse with activity, opening and closing slightly, as Enceladus orbits Saturn and is flexed by tidal forces. This means that Enceladus's blasts are controlled by a cycle or heartbeat. What about everyday life? We haven't found it yet, but if there is life in the ocean around Enceladus, it's most likely microbes that live near the ocean floor and around volcanic vents. The ocean is probably full of minerals and is very dark and salty. Cassini's plume data even showed hints of amino acids and carbon-based chemicals, but not in amounts that could be confirmed. New tasks will try to find the answer to this question. NASA and the European Space Agency have suggested missions like the Enceladus Orbolander, which is an aircraft and lander that works together to study the plumes, collect samples from the surface, and maybe even land near a tiger stripe. Enceladus is beautiful because its ocean is already leaking into space. This means that we might not even need to drill to study it. Visually, Enceladus is stunning. In Cassini images, it shines like fresh snow, reflecting nearly 100% of the sunlight that hits it. Its surface is pristine, rippled with ridges and scars, but mostly smooth, constantly resurfaced by falling snow from its own geysers. Mimas, the Death Star moon with a hidden heartbeat. At first look, Mimas, Saturn's moon, seems like nothing more than a joke. It's often called the Death Star moon. Yes, the similarity is really creepy. Its tiny cold surface is dominated by a single huge hole that makes it look like the Empire's most powerful weapon. But Mimas is actually a lot more interesting than its sci-fi doppelganger reputation makes it sound. With a diameter of just 396 kilometers, Mimas is one of the smallest spherical objects in the solar system. It barely made the cut to be round at all. Any smaller, and it wouldn't have had enough gravity to pull itself into a sphere. Its surface is heavily cratered, poked by collisions over billions of years, and almost entirely made of water ice. It reflects sunlight moderately well, but not as brilliantly as Enceladus. Instead, Mimas looks more worn, more tired, like an ancient relic that's just barely held itself together. The crater that gives Mimas its iconic identity is named Herschel, after the moon's discoverer, Sir William Herschel. The crater stretches an incredible 130 kilometers across, nearly a third of the moon's entire diameter. Its walls rise 5 kilometers high, and its central peak towers 6 kilometers above the crater floor. In images taken by NASA's Cassini spacecraft, Herschel appears so massive and proportionally exaggerated that it looks almost cartoonish. And it's not just for show. Scientists believe that if the impact that formed Herschel had been any larger, it would have shattered Mimas entirely. The moon likely came very close to destruction and somehow survived. For a long time, Mimas was dismissed as geologically boring. No plumes, no magnetic field, no subsurface oceans. It was just a cold, dead rock with a cool crater, or so we thought. In 2014, that assumption was quietly upended by a study of Mimas's orbital motion. Scientists analyzing data from Cassini found something strange. The moon was wobbling as it rotated, a phenomenon called libration. But the degree of libration was too large to be explained by a solid interior. There had to be something else inside causing the extra motion. The leading theory: a subsurface ocean, hidden beneath its frozen shell. That's right, Mimas, the moon once considered least likely to be active, may be hiding a global ocean of liquid water. If that ocean exists, it would be locked under at least 20 to 30 kilometers of ice, Unlike Enceladus, Mimas doesn't have geysers or visible cracks in its surface, but some researchers believe the ice shell could be young, unfractured, and newly formed, possibly covering a previously active body. This would make Mimas a kind of cosmic late bloomer, a moon that's just now entering a phase of internal heating. What could cause such heating? Tidal forces from Saturn are the most likely culprit. As Mimas orbits, the giant planet stretches and flexes it, generating internal friction and heat. This process, tidal heating, is the same force responsible for the eruptions of Io and the ocean of Enceladus. For Mimas, that heating may have just begun. If so, it could be in the early stages of an ocean-forming process, a snapshot of a moon in transformation. Furthermore, Mimas's odd temperature pattern adds to the mystery. The infrared sensor on Cassini showed something that no one expected. One side of the moon is warmer than the other, and it's not just because of the sun. The moon is warmer on the inside as well. What about the temperature map of that area? It looks like Pac-Man. NASA even called the strange object Pac-Man because of its unique shape. Some scientists think that this warm spot doesn't match up with any natural feature on the surface. This makes them think that it might be a sign of what's going on below, like a pocket of heat from tide stress or even frozen volcanic activity. Visually, Mimas's surface is barren. It has no atmosphere, no clouds, just ice and craters. Its heavily cratered terrain shows signs of some landslides, indicating loose regolith or shifting ground, but there are no obvious signs of tectonic motion or resurfacing. In some areas, craters overlap so densely that they create complex, jagged landscapes, frozen chaos sculpted by ancient collisions. In Cassini images, the terrain glows softly in scattered light, with shadows casting sharp relief across the worn ridges and rimmed basins. And yet, even this simplicity is deceptive. Because if Mimas does hold a subsurface ocean, then its outward quiet is just a mask. It would join the growing list of icy worlds, Europa, Ganymede, Enceladus, Titan, that may possess the conditions for life. It would show that even the most unassuming moon can hide a secret ocean in its core, waiting to be discovered. We don't have a mission planned for Mimas yet, but the discovery of possible subsurface liquid has reignited interest. It's now considered a priority target for future study, both for understanding ocean worlds and for tracing how moons evolve. It represents the threshold between frozen and fluid, silent and active, and studying that threshold may reveal how common or rare life-supporting environments are across the solar system. Iapetus, the yin-yang moon of Saturn. Iapetus, Saturn's third largest moon, is one of the strangest and most beautiful places in the solar system. It doesn't look much like a natural satellite, and more like a puzzle made out of ice and rock. One half is completely dark, and the other half is as white as snow. It has a huge line along the equator that goes around its middle like a scar from the planet. And because it spins so slowly, it only shows Saturn one face every 79 Earth days, which is one of the longest days of any big moon. Discovered by Giovanni Domenico Cassini in 1671, Iapetus confounded astronomers from the beginning. Cassini noted that the moon appeared bright when on one side of its orbit and dark when on the other. Today we know this is due to its extreme two-tone coloration. One hemisphere reflects nearly all the sunlight it receives, while the other absorbs almost all of it. This bizarre dichotomy earned it the nickname the yin-yang moon. But it wasn't until NASA's Cassini spacecraft flew past Iapetus in 2007 that we truly saw what was going on. In a false color mosaic, Iapetus appears as if someone spray-painted one side black and left the other untouched. The dark side is called Cassini Regio, and it stretches over the entire leading hemisphere, the side that faces forward as Iapetus orbits Saturn. The trailing side, by contrast, is covered in highly reflective water ice, a stark visual contrast that makes Iapetus one of the most visually unique objects in the solar system. So, what makes this strange duality happen? Most scientists think that Iapetus is picking up dark matter as it speeds through a space junk cloud. This junk is probably dust from Phoebe, one of Saturn's farther away backward moons. As Iapetus moves through this ring of dust, the particles build up on the main side and make it darker. But this is where things get crazy. The dark dust soaks up more sunshine, slightly warming the surface. The warmth makes close ice sublimate or turn straight into vapor and move toward colder places. As a result, a loop in which the dark gets darker and the bright gets brighter. This thermal migration theory is supported by high-resolution images from Cassini, which show areas where the boundary between light and dark isn't gradual. It's shockingly sharp. The contrast is so extreme that in some places, the terrain looks like it's been cut in half with a knife. You could step from snow into soot in just a few meters. But Iapetus has more than just a dramatic paint job. It also has one of the most mysterious geological features in the entire solar system, a massive equatorial ridge that encircles much of the Moon's waist. This ridge, visible in stunning detail in Cassini's close flyby images, rises up to 20 kilometers high and is hundreds of kilometers long. It looks like the seam of a poorly made baseball, except it's real, ancient, and towers above the surface like a frozen mountain chain drawn with a compass. No one is entirely sure how the ridge formed. Some theories suggest it could be the collapsed remnants of a ring system that once surrounded Iapetus, slowly falling back onto the Moon. Others propose it was created by internal tectonic forces, a result of the Moon spinning rapidly early in its history and then freezing into shape. A third hypothesis suggests that icy materials were somehow extruded through cracks, forming a chain of cryovolcanic peaks along the equator. What's particularly baffling is that the ridge is almost perfectly aligned with Iapetus's equator. That level of symmetry is rare in natural planetary processes and hints at a more complex and perhaps ancient geological history than this quiet, distant moon lets on. The surface of Iapetus tells additional stories of violence and age. It is heavily cratered, with impacts that span from small pockmarks to massive basins. The bright trailing hemisphere is dotted with craters filled with dark material, suggesting that dust from Cassini Regio occasionally migrates across the surface. In some places, the contrast is inverted. Dark craters on light terrain, possibly due to impacts that exposed the darker substrate beneath the ice. Cassini's close flyby in 2007 provided some of the clearest views of Iapetus ever taken. In these images, you can see the sharp ridges, rugged terrain, and transition zones between light and dark areas. The play of sunlight across the ridges makes the surface appear jagged and ancient, a relic of the solar system's youth that's been preserved in deep freeze. Despite its unusual features, Iapetus is not considered geologically active. It lacks the plumes of Enceladus, the storms of Titan, or the oceans of Europa. Its mysteries are buried in time, not motion, but that's what makes it valuable. Iapetus is like a time capsule, a body that hasn't changed much in billions of years. Its surface, coloration, and ridge may hold clues to early solar system dynamics, especially how small moons interact with dust, temperature, and rotational forces. There are currently no missions planned to revisit Iapetus, which is a shame. Its strange symmetry, dramatic color split, and towering ridge demand further study. If we sent a lander to Iapetus's equator, we could touch the edge of a ridge taller than Everest and walk from light to dark in just a few steps, something no other world offers. Tethys, Saturn's silent ice world etched with ancient scars. In the vast gallery of Saturn's moons, Tethys is often overlooked, quiet, pale, and cold. It doesn't erupt like Enceladus or shimmer with smog like Titan. It's not cracked in two-tone color like Iapetus. But Tethys has its own kind of grandeur. A world carved by collisions, shaped by frost, and haunted by the shadows of immense geological trauma. Tethys is the fifth largest moon of Saturn, with a diameter of about 1,062 kilometers, 660 miles. Composed almost entirely of water ice, it has the density of just 0.97 grams per cubic centimeter, less than liquid water. In many ways, Tethys is less a rock and more a giant snowball, a floating frozen relic from the solar system's icy outskirts. What it lacks in color, it makes up for with beautiful scenery. Ithaca Chasma, a huge depression that cuts through the moon's surface like a scar, is the most amazing thing about Tethys. This huge canyon is more than 1,000 kilometers long, up to 100 kilometers wide, and 5 kilometers deep. It covers almost 3/4 of the moon's diameter. This chasm would go from New York to Miami if it were on Earth. Captured in high-resolution images by NASA's Cassini spacecraft, Ithaca Chasma is a yawning reminder of Tethys's violent past. Scientists believe it may have formed when the moon's interior froze and expanded, cracking the surface like ice on a lake. The magnitude of the chasma's size and length makes it one of the most impressive tectonic features in the Saturnian system, and perhaps the clearest example of internal processes on what was long thought to be a geologically dead moon. Elsewhere on the surface, Tethys is heavily cratered, with impact scars dating back billions of years. But one crater dwarfs them all, Odysseus. This vast impact basin, over 400 kilometers in diameter, takes up almost 2/5 of the moon's entire width. Its central peak and raised rim are worn down, suggesting it's ancient. But even eroded, it dominates the surface like a hollow eye socket. When viewed from space, Odysseus gives Tethys the look of a cracked skull. A quiet world that's taken a beating and survived. What's fascinating is that an impact the size of Odysseus should have shattered Tethys completely. The fact that it didn't suggests the moon might have been partially molten at the time, allowing it to absorb the blow without breaking apart. That detail hints at a more dynamic past for Tethys, a time when its interior wasn't entirely frozen, and perhaps even mildly active. While Cassini flew by, he saw that Tethys is old and broken, but it's also beautiful in its simplicity. One very striking picture from April 2015 shows Saturn's glow shining on the icy rocks, crater edges and sunlit hills, creating long shadows across the white landscape. Every shot shows how light and shade, smooth and rough, stillness and memory are all different from each other. Tethys's surface is also home to mysterious dark material, particularly at the bottom of some craters. The origin of these dark spots is still uncertain. They might be deposits of carbonaceous material from outside sources, perhaps captured from space dust or delivered by micrometeorite bombardment. Or they may be resurfacing remnants, hints of some long-lost internal activity. In either case, their presence adds depth to an otherwise pale landscape. Interestingly, Tethys orbits Saturn in co-orbital resonance with two much smaller moons, Telesto and Calypso, which occupy its Lagrange points, gravitationally stable positions 60 degrees ahead and behind Tethys in its orbit. These Trojan moons are like cosmic bodyguards, drifting with Tethys as it encircles Saturn. No other major moon in the solar system shares this kind of dance, making the Tethys system a unique orbital family. Though Tethys shows little sign of current geological activity, there is evidence to suggest it once had a subsurface ocean that is now frozen solid. Gravity readings and surface mapping imply a differentiated interior, a rocky core surrounded by a thick, icy shell. While Enceladus still vents from its internal ocean, Tethys may have once had similar heat sources, but lost them, locking it into eternal cryogenic silence. Despite its frigid stillness, Tethys plays a role in Saturn's grand visual performance. Its icy surface reflects 80% of the sunlight it receives, making it one of the more reflective moons. And its presence in Saturn's mid-region, alongside moons like Enceladus and Dione, helps complete the portrait of a system brimming with diversity, each moon a different chapter in Saturn's sprawling celestial epic. What Tethys offers is time, uninterrupted time. Its surface tells the story of a world that formed early and has barely changed since. It carries the bruises of every impact, the stress marks of every tectonic event, and the quiet dignity of a moon that no longer moves, but still endures. Tethys is not flashy. It doesn't spew geysers or carry a magnetic field, but it doesn't need to. It is one of the purest geological archives in the outer solar system, a time capsule from an age when moons formed in shadows and survived in ice. It is the memory of motion, frozen in place. Next is Rhea, Saturn's second largest moon, where massive fractures cut through craters, and a ghostly ring may circle a silent world. Rhea, the ghost moon with fractured craters and a phantom ring. Rhea is a world of dull colors and old silence that floats quietly in Saturn's shadow. Rhea is not just another icy moon, it is Saturn's second largest satellite, measuring 1,527 kilometers, 948 miles, across. It has a history of tectonic upheaval, violent impacts, and maybe even a ring system, which is something no other moon in the solar system is known to have. At first glance, Rhea might seem unremarkable. Its surface is blanketed in craters, its color a dull grayish-white, and its rotation locked so that one side always faces Saturn. But with every close pass by NASA's Cassini spacecraft, this quiet moon revealed layers of complexity that completely defied expectations. Rhea's surface is divided into two very different faces. One is brighter and heavily cratered, preserving scars that date back nearly 4 billion years. The other side, slightly darker and smoother, shows signs of more recent geologic resurfacing. This contrast has puzzled scientists for decades. What could have caused one hemisphere to evolve so differently from the other? Then Cassini made one of his most important discoveries: cracks that cut through craters. Cassini took high-resolution pictures during close flybys in 2009 and 2010. These pictures showed huge tectonic features, like long, bright cracks that go straight through older impact areas. These cracks, which are some of the most dramatic and detailed pictures ever taken of Rhea, make the moon's face look like it has huge claw marks on it. The implications are fascinating. Rhea, long thought to be geologically dead, must have experienced some kind of internal stress or crustal shifting that pulled its icy surface apart, possibly during a period of heating or orbital realignment in Saturn's gravity field. These fractures show that the moon was once under pressure, its crust pulled and cracked like brittle glass under strain. The fractured highlands, combined with dense cratering, make Rhea a prime target for those studying the ancient solar system. Its surface is one of the most cratered in the Saturnian system, rivaling even Callisto in its cosmic pockmarks. Many of these craters have central peaks and concentric rings, resembling smaller versions of the massive Odysseus crater on neighboring Tethys. In 2008, scientists using Cassini's instruments detected strange anomalies in the space around Rhea. There appeared to be a disk of material circling the moon, a set of faint rings, possibly made of dust or icy debris. If confirmed, Rhea would become the first moon ever discovered to have its own ring system. The ring theory was supported by tiny blips in Cassini's charged particle data, suggesting particles were being blocked or absorbed by something orbiting Rhea. These invisible barriers couldn't be seen in optical images, but they behaved like rings. Later, imaging attempts tried to spot them, but so far, no definitive ring structures have been visually confirmed. Still, the idea remains tantalizing. Rhea may host a ghost ring made of extremely fine material, possibly the remnants of a small moon or impact debris. If this is true, it challenges our understanding of what moons can do, and what quiet satellites like Rhea might still be hiding in their gravitational fields. In one of the most detailed Cassini images of Rhea's surface, the limb of the moon glows in stark relief, with crater rims catching sunlight while shadows fall into deep, silent basins. The terrain appears ancient and undisturbed, a frozen record of impacts and fractures frozen into place. Another image, taken in 2010, shows Rhea illuminated like a ghostly lantern, its icy surface reflecting just enough light to outline its shape against the blackness of space. In this eerie portrait, Rhea looks like a forgotten relic, drifting through Saturn's realm like a quiet sentinel. Its internal structure is likely a rocky core surrounded by a thick mantle of ice, but there's no clear evidence of a subsurface ocean. It's colder, more static than its sibling Enceladus. But its heavily fractured crust, its possible rings, and its gravitational interactions with Saturn suggest a more complex past, one shaped by orbital evolution, tidal stresses, and violent encounters. Cassini's observations also suggest that micrometeoroid impacts continue to shape Rhea today, creating faint trails of ejecta and reshaping crater walls. Over time, this slow bombardment may be what's keeping Rhea's surface so pitted and rough, a constant process of small destructions echoing across millennia. If future missions return to Saturn, Rhea might once again become a prime candidate for study. A lander or orbital platform could reveal whether its suspected rings truly exist, what lies beneath its crust, and how its fractured terrain evolved. It may not have erupting plumes or colored atmospheres, but Rhea is a frozen journal, and every crack and crater is a written page. Next comes Dione, another icy enigma of Saturn's system, marked by bright wisps, tectonic scars, and the haunting possibility of an ancient ocean now sealed beneath frost. Dione, the moon of ghostly wisps and frozen faults. Dione is one of Saturn's icy moons. It may not have any plumes or bright atmospheres that stand out, but if you look below its calm surface, you'll find a world of ancient trauma, leftover warmth, and mysterious hints of a more active past. Dione spans about 1,122 kilometers, 697 miles, in diameter, placing it just behind Rhea in Saturn's family lineup. At a distance of around 377,000 kilometers from Saturn, it completes one orbit every 2.7 Earth days. Like many of Saturn's inner moons, it is tidally locked, always showing the same face toward its planet. But unlike its bigger sibling Rhea, Dione carries more than just impact scars. It wears the imprint of tectonic stress, crustal motion, and perhaps even the signs of a once warm interior. The first hint of Dione's strange story came from early Voyager flybys in the 1980s, which revealed a surface split between two faces. One hemisphere, smooth, bright, and covered in relatively few craters, stood in sharp contrast to the heavily pockmarked trailing side, which looked ancient and battered. But the hazy streaks were what really stood out. Bright lines, seen in Voyager pictures and later caught in amazing detail by Cassini, spread out like thin brushstrokes across Dione's trailing hemisphere. At first, scientists thought the wisps were ice layers from some kind of releasing activity. However, Cassini later showed that they were actually steep ice cliffs that show where the surface has pulled apart due to tectonic forces. In Cassini's high-resolution imagery, the wisps appear as glowing veins on an otherwise dark surface, vast icy walls that catch the sunlight and stretch for hundreds of kilometers. These features resemble fault scarps, where blocks of crust have shifted vertically in response to internal forces. Their very presence suggests that Dione has experienced intense stress and flexing, likely driven by tidal forces from Saturn and gravitational interactions with neighboring moons like Enceladus. This reshaping didn't happen yesterday, but it didn't happen at the solar system's birth either. The terrain suggests that Dione's surface has been reshaped at different epochs, with areas that appear relatively young, adjacent to ancient crater-saturated highlands. In some regions, impact craters are deformed or split by faults, proving that tectonic forces remained active after the period of heavy bombardment. One particular image from Cassini, taken in 2004 during its first close flyby, shows linear and curving fractures running across the bright terrain, like wrinkles frozen into the moon's icy skin. These features speak to global stresses, possibly from the expansion or contraction of the interior, or from a changing orbital resonance. Gravity data from Cassini suggested that Dione may have once harbored, or may still harbor, a subsurface ocean. While less obvious than the geysers of Enceladus, models based on Dione's shape, density, and gravity hint at a layer of liquid water sandwiched between its rocky core and icy shell. If confirmed, that would make Dione yet another ocean world, silently orbiting Saturn while keeping its liquid secrets locked beneath a crust of fractured ice. Some researchers even propose that Dione's past geological activity may have included cryovolcanism, although no definitive cryovolcanic features have been found. Still, the combination of ancient fault lines, resurfaced plains, and a potential interior ocean makes Dione far more than a static snowball. Unlike Enceladus, which gleams with a reflective white surface, Dione has a muted, slightly brownish tone, especially on the trailing hemisphere. This coloration may come from space weathering and dust accumulation, perhaps even from material swept up from the Phoebe ring or from impacts. Dione's leading side is significantly brighter, indicating it's being constantly refreshed, perhaps by micrometeorite impacts or charged particle bombardment from Saturn's magnetosphere. Cassini's long-term observations also showed evidence of exosphere interactions around Dione. A faint cloud of oxygen ions was detected near the Moon, extremely thin but notable. The source? Most likely sputtering, a process where energetic particles from Saturn's magnetosphere knock loose atoms from the icy surface. Though not a breathable atmosphere by any means, it shows Dione isn't completely inert. And like Tethys, Dione has a set of Trojan moons, Helene and Polydeuces, that occupy gravitational sweet spots 60 degrees ahead of and behind it in orbit. These smaller companions offer a chance to study how co-orbital systems evolve and interact in real time, acting as celestial bodyguards for their icy host. In Cassini's finest portraits of Dione, the Moon hangs in space like a cracked marble, glowing with soft light, its surface marked by graceful scars and time-worn craters. The bright wisps, once thought to be superficial coatings, now emerge as profound expressions of inner change. They are the bones of the Moon, exposed and frozen for all to see. There are no current missions planned to return to Dione, but if we want to understand the full range of ocean worlds and the forces that shape icy moons, Dione deserves another look. Beneath its quiet surface may lie an ancient ocean, a dormant heart, or even the final stages of a once lively interior slowly freezing into place. Miranda, the Moon built from broken pieces. Uranus is a faraway icy planet with a small moon that doesn't look like it should exist, at least not in one piece. Miranda is the name of the Moon, and it is one of the smallest known sphere moons in the solar system. Its diameter is only 472 kilometers, 293 miles. But this isn't about size. Miranda's surface is like a geological jigsaw puzzle. It's full of tall cliffs, jumbled terrains, and strange features that scientists used to joke that the Moon looked like a cosmic baby had broken it up and put it back together. Discovered in 1948, Miranda remained an enigma until Voyager 2 flew by Uranus in 1986. During its brief and only close pass, Voyager revealed just one side of Miranda, but what it showed left scientists stunned. The Moon's terrain is unlike anything else in the solar system. Deep grooves, massive ridges, rolling plains, and vast canyons all collide into a single landscape. It's not elegant. It's fractured, raw, wild. At the heart of Miranda's bizarre geography are its coronae, huge oval-shaped regions with concentric ridges and valleys, unlike anything seen on other moons. The most famous of these is Inverness Corona, a roughly 200-kilometer wide structure that looks like a target made of ice and stone. Recent geological mapping of the corona has revealed a complex arrangement of shear faults and compression features, suggesting intense tectonic stress that reshaped the landscape from below. Some areas appear older, pocked with craters, while others are remarkably smooth, young, geologically speaking. This implies that Miranda has undergone episodes of resurfacing, possibly driven by internal heating. But how could such a small moon, so far from the Sun and with so little gravitational pressure, generate the kind of energy needed to tear its crust apart? Its history might hold the key. Scientists think that Miranda was once stuck in a resonance orbit with another moon, maybe Ariel or Umbriel and Miranda. Miranda would have been stretched and bent by this gravitational contact, which would have heated its inside through tidal forces. Over time, the resonance broke and the heating went down. But not before the inside partly melted, letting cold material rise to the surface, crack it, and then freeze again into a mess of jagged edges. One of the most astonishing features on Miranda is a cliff called Verona Rupes, considered the tallest known cliff in the solar system. It rises somewhere between 15 to 20 kilometers, 9 to 12 miles, high, 3 times the height of Mount Everest. If you were to fall from the top, it would take you about 12 minutes to hit the bottom, even in Miranda's low gravity. These steep escarpments are likely the result of tectonic blocks being lifted and dropped along faults, exposing Miranda's inner structure like a peeled-back shell. Amidst the chaos are serene plains, where ice has resurfaced the land, erasing ancient craters and leaving behind a fresh, youthful appearance. Some of these areas resemble the chevron patterns seen in glacial flows on Earth, suggesting slow movement of ice in Miranda's past. Despite being so far from the Sun, Miranda reflects much of the little light it receives due to its icy surface. But it also shows patches of darker material, likely the result of radiation processing or the accumulation of space dust over eons. The contrast only deepens the impression that Miranda has lived through extremes, both inside and out. Miranda is especially interesting because it shows a type of moon that we don't study very often. We've been to ocean worlds like Europa and Enceladus, scary volcanic spheres like Io, and huge icy balls like Ganymede. But Miranda is different. It is a tectonically busy world that isn't big, hot, or atmospheric like most natural dramas. It's not okay. We've only seen a quarter of it so far. To this day, only one side of Miranda has ever been imaged in detail. The other remains a mystery. What lies there? More coronae? More cliffs? Perhaps smooth plains that contrast the chaos we've seen so far. Without new missions to Uranus, those questions remain unanswered. NASA and other space agencies have proposed missions to Uranus and its moons, with Miranda as a key target. A future orbiter could reveal the hidden side, study the interior, and perhaps even determine whether the moon still experiences any tidal activity. It might not have an ocean like Europa, but Miranda tells a different kind of story, one of destruction and reconstruction, of a moon that broke itself apart and tried to piece itself back together. Ariel, the shattered ice moon with hidden valleys. Out of Uranus's 5 main moons, Ariel is often dwarfed by Miranda, its more chaotic sister, or Titania and Oberon, its bigger partners. However, Ariel is one of the most geologically interesting moons in the outer solar system, so don't let its low public profile fool you. In fact, it could be the most active moon of Uranus. With a diameter of about 1,158 kilometers, 720 miles, Ariel is the 4th largest of Uranus's moons, and it boasts a surface that tells a story of violent upheaval, ancient resurfacing, and possible past internal warmth. Most of what we know about Ariel comes from the Voyager 2 flyby in 1986, which imaged only about 1/3 of the moon in detail. But even in that limited glimpse, Ariel revealed a fractured world shaped by time and tension. One of Ariel's defining features is its extensive network of canyons, chasms, and faults, many of which are long, straight, and steep-walled. These massive features are part of what scientists call graben structures, giant blocks of crust that have sunk between 2 parallel faults. The largest of these is the Cassini chasmata, which runs for hundreds of kilometers across Ariel's surface like a planetary scar. In Voyager's images, Cassini chasmata appears as a long, dark gash stretching across a relatively smooth and bright plain. The shadows inside the canyon reveal steep vertical walls and layered ice, suggesting that Ariel's crust is composed of sheets of frozen water that have been torn apart by tectonic stress. These grabens and canyons are signs of global expansion, possibly caused by the freezing of a once liquid interior. As the inner ocean froze and expanded, the outer crust cracked and stretched, leaving behind deep grooves and cliffs. Compared to its sibling moons, Ariel has fewer large impact craters, especially in certain regions. This implies that portions of its surface were resurfaced at some point in the moon's history. The smoother terrains are likely the result of cryovolcanic flows, frozen slurries of water and ammonia that once oozed from Ariel's interior, flooding older terrain and hardening into smoother plains. In false color images, some of these resurfaced regions appear as pale blue or green, contrasting sharply with the darker, older highlands. One notable feature is a large bright crater called Leica, which lies in a relatively smooth region. The crater's edges are sharp, but the floor looks subdued, as if softened by underlying or later activity. Ariel also has areas that appear ridged and wrinkled, much like tectonic compression features seen on icy moons like Ganymede. These ridges may have formed after the surface cooled and contracted, pushing material upward into long, low hills. This combination of ridges, canyons, and smooth plains suggests that Ariel underwent multiple episodes of geological activity, possibly driven by tidal heating early in its life. This internal heat might have come from gravitational interactions with Uranus and neighboring moons. While Ariel isn't currently in a significant orbital resonance, it may have passed through such configurations in the past. Like Miranda and Enceladus, Ariel may have experienced brief but intense periods of tidal flexing, generating enough internal friction to power cryovolcanism and tectonic shifts. Unlike Enceladus or Europa, Ariel shows no evidence of active plumes or a present-day subsurface ocean. But that doesn't mean it's dry and dead. The varied terrain, young surfaces, and fractured crust all point to a complex and evolving geological history. If Ariel once had a liquid ocean, it may still exist today, locked beneath a thick frozen shell. And if heat lingers in the core, the story may not be over. More trips to Uranus might help solve the rest of Ariel's secrets. We don't know what's on the night side because we've only taken detailed pictures of a third of its surface. There could be more chasms, younger flows, or even signs that things are changing over time. A pars or satellite with radar and infrared sensors could find out if Ariel is still active, what its structure is like on the inside, and if there are conditions for life below its icy surface. Ariel's looks are a study in contrast. It looks quiet and white from far away because it reflects about 35% of the sunlight that hits it. But up close, it's a world of cracked crusts, landslides, and scars left by glaciers. It is both still and moving, old and new at the same time. Triton, Neptune's captured giant with geysers of ice. A moon far away in the frozen parts of the solar system spins in a way that doesn't follow the rules. It breathes nitrogen and has icy geysers coming out of a shell that looks like it was shaped by chaos. This is Triton, the biggest moon of Neptune. It is also one of the strangest and most busy planets we've ever seen. Triton is 2,706 kilometers, 1,680 miles, across, making it the seventh largest moon in the solar system, even bigger than Pluto. But it's not its size that makes Triton so special. It's its retrograde orbit. Triton moves in the opposite direction of Neptune's rotation, unlike every major moon in the solar system. That fact alone is a massive clue. Triton wasn't born here. It was likely captured by Neptune's gravity, possibly a former dwarf planet that once roamed the Kuiper belt, only to be snared by the ice giant in a dramatic gravitational encounter. When NASA's Voyager 2 passed by Triton in 1989, it revealed a surface that was completely unexpected. Smooth, bright, and incredibly reflective, Triton's crust looked young. There were few impact craters, and many regions looked like they'd been reshaped not millions, but perhaps only thousands of years ago. And then came the shock. Voyager spotted geysers erupting, not of water, but of nitrogen gas, shooting over 8 kilometers, 5 miles into the sky. These geysers left dark streaks across the surface, trailing downwind in patterns shaped by Triton's thin atmosphere. At the time, this was the first active cryovolcanism ever seen beyond Earth, proof that even in the outer solar system, moons could still move and breathe. The likely cause? Triton's surface is coated in frozen nitrogen, and when sunlight hits a translucent layer of this ice, it warms the material underneath. Eventually, the pressure builds, and the nitrogen vents explosively, dragging dust and dark particles along for the ride. These aren't isolated flukes. Voyager spotted several geysers and evidence of many more. This activity implies that Triton is still geologically alive. One of Triton's most iconic features is the cantaloupe terrain, a vast region covered in bulbous, wrinkled hills and dimples that resemble the skin of a melon. Seen in Voyager 2's images, this landscape is totally unique, found nowhere else in the solar system. Scientists believe it formed from diapiric upwellings, slow bubbles of warmer ice rising through colder layers, deforming the crust from beneath like a squeezed balloon. Cutting across the cantaloupe terrain are long icy faults known as sulci, ridges and valleys like Slidder sulci and Tano sulci. These suggest tectonic stretching, like the skin of the moon is being slowly pulled apart. In some places, it looks as if entire regions have been resurfaced by internal forces, wiping out older craters and laying down fresh ice. In fact, Triton's surface is one of the youngest in the solar system, possibly less than 100 million years old, and maybe far younger in some regions. That's shocking for a moon this far from the Sun, with no massive parent moon to stir it gravitationally, like Io or Enceladus. So where is Triton getting its energy? Some scientists suspect that radioactive decay in its core may still be providing enough heat to keep Triton's interior partially active, possibly even harboring a subsurface ocean beneath the frozen crust. There's no direct evidence of this ocean yet, but the cryovolcanism, faulting and young terrain are strong hints. If such an ocean exists, it would be trapped beneath kilometers of ice, potentially kept warm by salts, ammonia, and residual tidal heating from its tilted orbit. There's also Triton's mood, which is tense but real. It's mostly nitrogen with some methane in it, and it's thick enough to hold wind and thin clouds. Voyager 2 saw a thin haze, and current telescopes on Earth have seen changes in the seasons, such as higher air pressure. These changes are likely caused by sunlight moving nitrogen frost into and out of vapor. Unfortunately, Voyager 2 remains the only spacecraft to have ever visited it, and that flyby was just 5 hours long. But in those 5 hours, it revealed a moon that seems custom-built to challenge assumptions. A captured world, a retrograde orbit, geysers, cantaloupe plains, tectonic faults, and maybe even oceans. Some of NASA's future mission concepts, like the Trident flyby mission, hope to return, with instruments designed to search for plumes, map the terrain, and sniff for signs of habitability. Charon, the split-faced companion to a distant world. When NASA's New Horizons probe flew by Pluto for the first time in history in July 2015, it changed the way we think about one very faraway world and showed us another one that was right there in front of us. Charon is that other world. It is Pluto's biggest moon. It was once thought to be a dull, frozen satellite, but it turned out to be a natural discovery. At 1,212 kilometers, 752 miles wide, Charon is half the size of Pluto, making it the largest moon relative to its parent planet in the entire solar system. In fact, the Pluto-Charon system is sometimes referred to as a binary dwarf planet because both bodies orbit a common point in space that lies outside Pluto itself. They're locked in a cosmic dance, always showing the same face to each other, eternally twinned in their icy orbit beyond Neptune. Charon's surface is nothing like Pluto's. While Pluto dazzles with colorful patches of red, brown, and white nitrogen ices, Charon is more subdued, dressed mostly in muted grays and browns. But don't let that fool you. Charon is carved with massive canyons, scarps, and fractured crust, evidence of ancient internal violence and perhaps even a global transformation. A system of huge chasms that run around much of Charon's equator is one of the most interesting things that New Horizons saw. Serenity Chasma is the longest and deepest of these canyons. It is over 1,800 kilometers long, which is almost twice as long as the Grand Canyon. It may have formed when Charon's innards grew bigger, which cracked its cold shell as a once liquid ocean below the surface froze and grew bigger, ripping the crust apart from the inside out. Charon's southern hemisphere is smoother and appears geologically younger. A massive cryovolcanic plain, known as Vulcan Planum, stretches across this area, marked by signs of frozen lava flows, water ice mixed with ammonia that may have erupted from within during a brief period of internal heating. In some images, these plains resemble ancient lakebeds, now frozen solid for billions of years. But perhaps the most enigmatic part of Charon is what scientists nicknamed Mordor macula, a large, dark red blotch staining the Moon's north pole. This patch, so distinctive in the otherwise neutral landscape, appears to be made of complex hydrocarbons called tholins, which are created when methane from Pluto's escaping atmosphere is captured by Charon and transformed by ultraviolet radiation. In other words, Pluto is painting its moon, drop by drop, molecule by molecule. These hydrocarbons then freeze onto Charon's frigid surface, creating a seasonal polar hood that stains the pole in crimson. The discovery suggests a surprising chemical interplay between a planet and its moon, driven not by tectonics or heat, but by the delicate transfer of atmosphere across space. Charon's landscape is a chronicle of frozen upheaval. The surface shows signs of tectonic stretching, resurfacing, and strange ridges that hint at a complicated internal past. New Horizons images even revealed evidence of possible cryogeysers, though none were active during the flyby. If confirmed, these could point to a residual heat source deep beneath the ice, a glimmer of motion in a place that should be utterly still. So far, only one hemisphere of Charon has been seen in high resolution. The far side, always turned away from Pluto, remains unexplored. What lies there? More chasms, hidden plains, another polar surprise. The answers are waiting in darkness, on the other side of a moon that refuses to be ordinary. Hydra, the tumbling shard at the edge of Pluto's realm. NASA's New Horizons probe flew quickly through the Pluto system in July 2015. It took stunning pictures of Pluto and its big partner Charon. It also pointed its cameras at a few much smaller moons that had been just dots in space up until that point. Hydra, the farthest out of Pluto's 5 known moons, stood out as a broken, glowing piece of frozen mystery. Hydra is tiny, just roughly 43 kilometers, 27 miles, across at its widest. But what it lacks in size, it makes up for in movement. Unlike most moons in the solar system, which have settled into synchronous rotation, Hydra does not keep one face toward Pluto. Instead, it spins chaotically, tumbling unpredictably as it orbits its dwarf planet host. It completes a rotation every 10.3 hours, a rapid spin for such a small body, especially one shaped more like a potato than a sphere. The cause of this unusual behavior is gravitational tug-of-war. Pluto and Charon form a binary system, where both bodies orbit a shared center of mass. This creates a shifting gravitational field that keeps Hydra and its fellow small moons off balance, constantly altering the torque applied to their rotations. As a result, Hydra doesn't spin like a top, it stumbles like a drunk satellite, its orientation never repeating the same way twice. In fact, some models suggest that it may never have the same night twice, a surreal prospect for a place where a single sunrise might take centuries to repeat. Images from New Horizons showed Hydra to be irregular in shape and covered in bright water ice, making it one of the most reflective objects in the Pluto system. Its surface appears relatively smooth, with few obvious impact craters. Though given the low resolution of the imagery and the moon's size, it's possible we're simply missing the finer details. Still, that smoothness hints at either a young surface or one frequently refreshed by micrometeoroid impacts, ice redistribution, or even ancient collisions that shattered and reassembled the moon. One of the most surprising findings from the New Horizons data was just how bright Hydra is. The moon reflects about 83% of the sunlight that hits it, much higher than expected for such a small, distant object. This suggests a surface covered in clean, crystalline water ice, likely the result of impacts that exposed fresh material or frost processes driven by interactions with Pluto's extremely thin atmosphere or faint solar radiation. Unlike Pluto's larger moons, Hydra is so small that it's unlikely to be geologically active. Its shape, elongated and uneven, indicates that gravity wasn't strong enough to mold it into a sphere. It's a captured relic of the system's past, possibly formed during the massive impact that created Charon. In this theory, debris from the Pluto-Charon collision coalesced into smaller moons like Nix, Kerberos, Styx, and Hydra, each trapped in orbits sculpted by the complex gravitational ballet of their larger neighbors. Hydra orbits Pluto at a distance of about 64,700 kilometers, 40,200 miles, farther out than any other known moon in the system. It takes 38 days to complete one orbit, and because the Pluto-Charon binary wobbles and spins as well, Hydra's path is anything but stable in the long term. It's constantly being nudged, pulled, and tilted by gravitational interactions that keep its spin state in chaotic flux. In the near true color image taken by New Horizons, Hydra appears grey-white, mottled and softly illuminated, a distant shard of frozen history drifting on the outskirts of Pluto's influence. Its very presence serves as a reminder of how strange and unstable the outer solar system can be. Nothing here behaves quite the way we expect, and Hydra is a prime example of that uncertainty carved into motion. Our researchers from far away have just shown us alien cliffs, atmospheric tides, frozen seas, and scars on the planet that are older than Earth's continents. All of these things have been caught in light and shadow. But there's a lot more out there than Pluto's edge. More stars, even more questions, and maybe someday more signs of life. If this look at the newest pictures of space has piqued your interest, you can subscribe to Beyond Horizons to see more in-depth looks into the strange and beautiful parts of our world. We're only beginning to talk about things like rogue planets and ice mountains.